What if the universe isn't just a vast, infinite sea of stars, but rather a complex web of mysteries stretching far beyond the reach of our understanding? A place where what we know may only scratch the surface of what truly exists. Scientists have uncovered a shocking reality. Nearly 95% of the universe is composed of something we can neither see nor directly interact with: dark matter and dark energy. These enigmatic forces, while invisible to our eyes, wield an enormous influence on everything in the cosmos. They shape the very structure of space itself, affecting the behavior of galaxies, stars, and even the fabric of time. But despite their vast presence, dark matter and dark energy remain elusive, their true nature a profound riddle that we have yet to solve. As we venture into the realm of the unknown, we're left wondering what might exist just beyond the edges of the observable universe. What unseen forces, matter, and phenomena could be out there, waiting for discovery? Could there be vast, untapped realms beyond the stars and galaxies we can detect? These are questions that spark our imagination, urging us to look deeper into the cosmic abyss. The universe is undeniably vast, but even the observable universe, the portion we can study and measure, is just a minuscule fraction of what may lie beyond our vision. One of the most compelling pieces of evidence suggesting there's far more out there than meets the eye is a phenomenon known as gravitational lensing. When massive objects, like galaxy clusters, bend the fabric of space and time, they can also bend the path of light coming from more distant galaxies. This distortion acts as a cosmic magnifying glass, revealing galaxies that would otherwise remain hidden from us. It's as if these galactic structures are waiting just out of reach, their light altered but still perceptible when we observe the universe through the lens of powerful instruments. Gravitational lensing not only unveils distant cosmic objects, but it also hints at the existence of even more galaxies lurking in regions of space that appear completely dark to our naked eye. Then there's the cosmic microwave background radiation, the faint afterglow of the Big Bang that has echoed across the universe since its inception. While it might seem like just background noise, scientists have detected subtle temperature fluctuations in this radiation that could reveal something astonishing: the potential presence of galaxies and cosmic structures that are still hidden from our current observational reach. By studying these fluctuations in ever greater detail, researchers are beginning to piece together a picture of a universe much richer and more complex than we ever imagined. What they're uncovering suggests that there could be vast collections of galaxies lying just beyond the observable horizon, waiting to be discovered once we have the tools to look further into the depths of space. But perhaps one of the greatest challenges in observing the farthest corners of the universe comes from the very nature of its expansion. Since the Big Bang, the universe has been steadily stretching outward, with galaxies moving farther and farther away from us. As space expands, the light emitted by these distant galaxies shifts to longer wavelengths, causing them to appear redder. This phenomenon, known as redshift, can make it impossible for us to observe some of the farthest galaxies because their light is stretched beyond the visible spectrum, rendering it invisible to our instruments. Some galaxies may even be receding from us so rapidly that their light will never reach Earth, forever keeping them hidden from our observation. Redshift not only alters our perception of distant galaxies, but also suggests a mind-boggling possibility. For every galaxy we can see, there could be countless others that are simply too far away for us to detect. Galaxies that remain out of view, obscured by the very expansion of the universe itself. In the end, each new discovery, each breakthrough in our understanding of the cosmos only deepens the mystery. What is out there, just beyond the edge of our perception? What could we uncover if we could see further, understand more, and delve deeper into the very forces that govern the universe? The answers remain tantalizingly out of reach, but one thing is certain: the universe is far more mysterious and far more vast than we can even begin to comprehend. And the more we learn, the more we realize that what we can see may only be the beginning. Advancements in technology and observational techniques are continuously pushing the limits of human understanding, revealing ever deeper layers of the cosmos. With tools like the James Webb Space Telescope, astronomers are now able to peer further into space, collecting data that unveils structures and phenomena far beyond the limits of our current observational horizon. Each new discovery ignites a growing realization that the universe may be much richer in galaxies, nebulae, and cosmic wonders than we ever imagined. This expanding knowledge not only deepens our understanding of the universe, but also fuels an ongoing sense of awe and curiosity about the vast and enigmatic cosmos surrounding us. The concept of the observable universe is rooted in the idea of distance, measured by the time it takes light to travel across the cosmos. Scientists define this boundary as the furthest point from which light has had time to reach us since the beginning of the universe, a journey that began approximately 13.8 billion years ago. The observable universe, therefore, forms a spherical boundary around us with an estimated radius of 46.5 billion light-years. But this boundary is not a fixed one, as the universe itself is expanding. As a result, regions of space that once appeared to be closer are now far farther away, altering our perception of the cosmos. This expansion of space introduces a unique complexity to our understanding of the universe. As we look outward, we are not simply observing stars and galaxies as they are in the present moment, but as they were when their light first began its journey towards Earth. What we see is a snapshot of the past, often millions or even billions of years old. This time delay means that each observation of the cosmos is a glimpse into ancient history, requiring careful interpretation within the context of an ever-expanding universe. The farther we look, the further back in time we peer, offering us a deeper understanding of cosmic evolution. However, this sense of exploration quickly runs into the limits of what we can observe. Beyond the observable universe lies a vast expanse that remains hidden from our view. The light emitted from regions beyond our observational limits has yet to reach us, making it impossible to directly observe these distant realms. Theoretical models can offer potential insights into what might lie beyond, but direct observation remains a distant dream. The laws of physics, as we currently understand them, may not even apply in the same way in these far-flung reaches, prompting questions about the very nature of space and reality itself. This search for knowledge extends into some of the most profound and speculative areas of science, particularly in the realm of cosmology. Theoretical frameworks such as the idea of a multiverse, a collection of parallel universes or dimensions, have gained traction, though they remain largely untestable with current technology. These speculative ideas challenge the boundaries of our understanding and push the field of cosmology into new conceptual territories. Yet, as we continue to push the frontiers of space exploration and theory, we are reminded that there is still so much we do not know, and the quest for understanding the full extent of our cosmic surroundings remains as exciting and compelling as ever. One of the greatest challenges facing scientists today lies in the study of dark matter and dark energy, two mysterious components of the universe that play crucial roles in shaping its structure and evolution. Despite being invisible and undetectable through conventional means, dark matter is thought to constitute about 26% of the universe. Its gravitational effects are essential for explaining the formation and behavior of galaxies, particularly in regions that are beyond our ability to directly observe. Without dark matter, the observed rotation speeds of galaxies would be impossible to explain. This unseen substance effectively acts as a cosmic glue, holding galaxies together and influencing the way they cluster in space. Dark energy, on the other hand, is an even more elusive force. It is believed to account for roughly 70% of the universe and is thought to be responsible for the accelerating expansion of the cosmos. First detected through observations of distant supernovae in the late 20th century, dark energy is reshaping our understanding of the large-scale structure of the universe. As galaxies drift apart at increasing speeds, dark energy's influence becomes ever more apparent, particularly at the outermost edges of the observable universe. Its impact forces scientists to rethink long-standing assumptions about the cosmos, pushing the boundaries of our understanding and prompting questions about the ultimate fate and structure of the universe itself. The interplay of dark matter and dark energy presents a profound challenge to our intuitive understanding of the universe. They compel scientists to revisit existing theories and frameworks, leading to new, unexpected questions about the very fabric of reality. As we probe deeper into the mysteries of the universe, we must reconsider how forces within galaxy clusters as well as the vast voids between them interact. The combined effects of dark matter and dark energy have the potential to reshape our understanding of the universe's fate, urging us to explore the fundamental forces that govern cosmic evolution. The search for exotic forms of matter beyond the reach of our current observational capabilities has also become a central focus in the field of theoretical physics. Among the most intriguing ideas is that of dark matter itself, an invisible substance believed to make up a significant portion of the universe. Unlike ordinary matter, dark matter does not interact with electromagnetic forces, making it incredibly difficult to detect. Its presence was first hypothesized to explain discrepancies in galactic rotation rates and the gravitational effects that could not be accounted for by visible matter alone. One fascinating theory surrounding dark matter involves axions, proposed elementary particles thought to be key components of this mysterious substance. These particles are theorized to be exceptionally light and interact weakly with other forms of matter, making them nearly impossible to detect directly. If axions do exist, they could not only provide a solution to the dark matter puzzle, but also offer crucial insights into the fundamental forces and symmetries of nature. Another exotic concept gaining attention is that of negative mass, an unusual form of matter that would behave in opposition to our usual understanding of mass. In the presence of a gravitational field, ordinary mass attracts, while negative mass would theoretically repel. This counterintuitive property could lead to strange and extraordinary phenomena, including the possibility of warp drives for faster-than-light travel. Such ideas, while speculative, have captured the imagination of scientists and science fiction enthusiasts alike, offering tantalizing glimpses of what might one day be possible. As we continue to probe the outer limits of our knowledge, the mysteries of dark matter, dark energy, and exotic forms of matter push the boundaries of both theoretical and observational science. Each new discovery brings us closer to unraveling the complex and ever-evolving tapestry of the universe, though many questions remain unanswered. Our understanding of the cosmos is far from complete, and the journey to explore its vast uncharted reaches promises to be one of the most exciting and profound scientific endeavors of our time. Finally, researchers have proposed the intriguing idea of quantum foam at the Planck scale, a concept that hints at highly energetic fluctuations within the very fabric of space-time. This suggests that reality, at a microscopic level, is far more dynamic and ever-changing than we currently understand. At this scale, the foundation of the universe itself might be in constant flux, potentially leading to the emergence of forms of matter and energy that remain completely beyond our perception and measurement capabilities. Each of these theories offers a unique glimpse into the vast and complex puzzle of the cosmos, drawing scientists deeper into the unknown and unveiling layers of mystery that continually challenge our understanding of the nature of existence. Cosmic inflation, a theory that posits the universe underwent an exponential expansion immediately following the Big Bang, plays a crucial role in shaping the cosmos we observe today. This period of rapid expansion, lasting from mere fractions of a second to a few minutes, propelled vast regions of space far beyond our current observational limits. These regions, now forever beyond our reach, contribute to the fascinating notion of cosmic anomalies that remain hidden from view. This brief yet significant moment in the universe's history not only shaped the large-scale structure of the cosmos, but also leaves us pondering the existence of other regions we may never see. As the universe continues to expand, a force known as dark energy drives this ever-accelerating growth. Galaxies are steadily moving away from us, and in doing so, they stretch into regions of space that may be permanently inaccessible to observation. Over time, this expansion causes light from distant objects to stretch and shift out of the observable spectrum, limiting our view of the vast universe. This phenomenon presents the possibility that there are entities, forces, or phenomena residing beyond our observational capabilities. These could include exotic forms of matter like dark matter, unknown cosmic structures, or even advanced civilizations that have developed in regions we are unable to detect. Furthermore, as technology and observational techniques continue to evolve, scientists are pushing the boundaries of what we can observe. Yet, despite these advancements, the sheer scale of the universe means that an infinite array of potential anomalies could exist just beyond our reach. Anomalies such as cosmic strings or variations in the cosmic microwave background radiation may lie within these unreachable realms, holding secrets that could challenge our very understanding of the laws of physics. The interplay of cosmic inflation and the ongoing expansion of the universe suggests a cosmos teeming with mysteries waiting to be uncovered. This dynamic process not only highlights the limits of our current scientific inquiry, but also ignites a profound sense of wonder about the vast unknowns that still lie beyond our grasp. As we venture deeper into the cosmos, we are continuously reminded that the universe is not merely composed of what we can observe, but also what remains hidden from view. These unseen realms invite us to ponder the infinite possibilities that could exist just out of reach. At the very boundaries of our understanding, the exploration of space and time faces extraordinary challenges. Scientists believe that the edge of the observable universe is not simply a static boundary, but a dynamic frontier, where the familiar laws of physics begin to break down. Phenomena at this limit suggest that our perception of space and time is far more intricate than we currently realize. One of the most compelling aspects of this frontier is the behavior of light at the edge of the observable universe. Light from the most distant galaxies takes billions of years to reach us, meaning we are seeing them as they were in the distant past. This creates a sense of immense distance and introduces the concept that time itself may operate differently on cosmic scales. The universe's expansion results in galaxies receding from us faster than the speed of light, challenging our fundamental understanding of time itself. While we can observe the light from these distant stars, once they exceed a certain distance, they are forever beyond our reach, emphasizing the paradox of a universe that is both infinite and yet constrained by our limited perception. Another fascinating concept is the cosmological horizon, which marks the furthest distance from which light has had time to reach us since the Big Bang. This boundary reveals how time itself behaves in ways that defy our expectations. The universe's accelerating expansion stretches space in such a way that regions near the cosmological horizon are not only far away, but also occur within a different temporal framework. What we perceive as vast stretches of space are actually filled with gaps in our understanding of time, urging us to rethink our linear view of reality. In addition to these challenges, the intersection of quantum physics and relativity adds yet another layer of complexity to our exploration of the universe's limits. Quantum entanglement and fluctuations suggest that particles can become intertwined in ways that defy our traditional notions of space and distance. These phenomena imply that at the boundary of the universe, the familiar principles of space and time may not apply in the way we expect. What we once believed to be intuitive concepts may just be a small part of a much larger and more intricate cosmic puzzle, one that is still unfolding. Gravitational waves, ripples in the fabric of space-time created by some of the universe's most cataclysmic events, such as black hole collisions or neutron-star mergers, offer another fascinating insight into the unseen aspects of the cosmos. When these powerful events occur, they send out waves that can be detected here on Earth, revealing not just the nature of the events themselves, but also providing glimpses into the broader universe beyond our direct observation. The detection of these gravitational waves has opened a new window into the mysteries of the cosmos, hinting at anomalies or phenomena that could be taking place beyond the observable universe, in regions whose light has yet to reach us. Through the study of these waves, scientists are beginning to realize that there may be entire structures or events occurring far beyond our observational reach. These waves carry vital information about the sources of their origin, information about their masses, distances, and movements, which may suggest the existence of objects or phenomena we are unaware of. For instance, the detection of particularly energetic gravitational waves could point to the presence of massive, unseen objects, or perhaps even entire gravitational interactions taking place in regions of the universe that we can only begin to imagine. In sum, the detection of gravitational waves and the study of anomalies in spacetime invite us to explore not only the visible cosmos, but also the vast, hidden realms that lie just beyond the edge of our perception. They challenge us to rethink our understanding of space, time, and reality, and open the door to a new era of cosmic discovery. As we continue to peer into the depths of the universe, we are reminded that there is much more to the cosmos than what meets the eye. The mysteries of the universe beckon us forward, urging us to explore not only the stars we can see, but also the countless wonders that may forever remain just out of reach. Gravitational waves, those faint ripples in spacetime, are more than just an astronomical curiosity. They carry with them potential revelations that could forever alter our understanding of the universe. By studying how these waves propagate, scientists are unlocking clues about the enigmatic forces that govern the cosmos, particularly the mysterious substances known as dark matter and dark energy. Together, these two components make up a vast majority of the universe's total energy density, yet remain largely invisible to our current instruments. Some theories suggest that areas of gravitational waves might hold the key to identifying the influence of dark matter and dark energy. These waves could point to anomalies or phenomena that are shaped by these elusive forces. This raises profound questions about the very nature of the universe, questions about how it has evolved, how it continues to expand, and how dark energy and dark matter intertwine with its unfolding story. Gravitational waves serve as a bridge between the visible and the invisible, linking our understanding of the known astrophysical universe to the unseen, hidden forces that may lie beyond our perception. In many ways, they challenge everything we thought we knew about space, time, and the fundamental fabric of reality itself. As these waves ripple through spacetime, they may reveal new layers of cosmic mystery. Each disturbance in the fabric of the universe could carry insights into the deeper workings of the cosmos, suggesting that what we observe with our current instruments only be a fragment of a far larger, more intricate reality. More intricate gravitational waves urge us to consider the possibility of what lies beyond the observable universe, an area that remains shrouded in mystery but could soon be illuminated by future discoveries. One of the most tantalizing possibilities that these waves hint at is the idea of parallel universes. For decades, the notion that there might be other universes existing alongside our own has captured the imaginations of both scientists and the public alike. But this idea is not purely speculative. It is grounded in several lines of theoretical inquiry, particularly within the field of cosmology. Cosmologists have long been intrigued by the concept of inflation, the rapid expansion of the universe that took place in the moments following the Big Bang. This inflationary period may have expanded the universe exponentially, creating the potential for multiple universes to emerge, each with its own unique properties and physical laws. In this view, the universe we see is just one of many, a part of a grander cosmic tapestry. At the same time, quantum mechanics offers another path to understanding parallel universes. The many worlds interpretation proposes that every quantum event spawns a branching of realities, creating distinct universes for each possible outcome. According to this theory, there could be an almost infinite number of parallel universes, each one representing a different version of reality. While the theory remains highly speculative, it opens the door to a new way of thinking about the structure of the universe and the fundamental nature of existence. Observations of cosmic microwave background (CMB) radiation, the faint afterglow of the Big Bang, have provided additional support for these ideas. Anomalies and irregularities detected in this radiation might hint at the presence of other universes. Some scientists speculate that collisions between our universe and neighboring universes could leave behind imprints on the cosmic backdrop, offering direct evidence of interactions between our realm and others that exist beyond our perception. String theory, which seeks to unify the fundamental forces of nature, adds yet another layer to this puzzle. This theory posits the existence of extra dimensions beyond the familiar three-dimensional space we experience. In this framework, a multiverse could exist, a vast collection of universes, each governed by its own set of physical laws. Although concrete evidence for string theory remains elusive, its mathematical framework has generated substantial interest, pushing researchers to explore deeper into the structure of the cosmos and the possibility of multiple universes. As astronomers continue to study the expansion of the universe and unravel the mysteries of the fabric of reality, the prospect of parallel universes becomes ever more intriguing. We are inching closer to answering profound questions about whether we are truly alone in the cosmos, or whether there are other realms beyond our reach. With each new breakthrough, we move closer to exploring the possibility that the universe we observe is just one piece of a far grander and more complex cosmic landscape. As we look to the future, the potential for technological advancements to push the boundaries of our exploration is nothing short of thrilling. Today, we have telescopes and instruments that allow us to observe phenomena beyond our wildest imaginations, black holes, dark matter, and cosmic anomalies that challenge our understanding of physics. However, these tools are only the beginning. As technology advances, so too does our ability to peer deeper into the farthest reaches of the universe. One of the most exciting developments on the horizon is the advent of next-generation space telescopes. These sophisticated instruments will employ cutting-edge imaging techniques, enabling astronomers to capture stunningly detailed observations of distant galaxies, nebulae, and other cosmic phenomena that were previously hidden from view. For example, telescopes that operate across a broader range of the electromagnetic spectrum will be able to detect signals that current optical telescopes miss. This could open new windows into the nature of dark energy, a mysterious force that is driving the accelerated expansion of the universe. In addition to these advancements, the rise of artificial intelligence, AI, holds the promise of revolutionizing how we process and analyze the vast quantities of data generated by these new observations. Machine learning algorithms can sift through massive amounts of data, identifying patterns and anomalies far more efficiently than any human could. This capability will allow scientists to draw more meaningful conclusions from the data they collect, potentially leading to groundbreaking discoveries about the universe and its hidden workings. As we continue to uncover the secrets of the cosmos, from the study of gravitational waves to the development of next-generation telescopes and AI-driven data analysis, humanity is on the cusp of an exciting new era in astrophysics. What lies ahead in this vast, unexplored ocean of space is still largely unknown. But with every new discovery, we draw closer to the truth, and the boundaries of our understanding expand ever further. The universe is a mystery, but we are on the path to unlocking its deepest secrets. The convergence of collaboration within global scientific communities, made more efficient and dynamic through advanced communication technologies, has opened an unprecedented frontier in the exploration of the cosmos. These technologies facilitate real-time discussions among scientists across the world, enabling them to share discoveries, engage in collaborative research, and work together on ambitious projects aimed at understanding the deepest mysteries at the edges of the universe. In this era, humanity is no longer relegated to the role of mere observers gazing at the stars. Instead, we stand at the threshold of a new chapter in cosmic exploration, one where the once unimaginable goal of understanding the enigmatic boundary of the universe may soon shift from science fiction to tangible reality. With each new advancement, we uncover more about galactic structures that defy our current understanding of the cosmos, leading to profound implications for the field of cosmology. When astronomers detect formations or phenomena that don't align with existing models, it sparks a reevaluation of the fundamental principles that underpin our understanding of cosmic evolution. These anomalies suggest that our comprehension of dark matter, dark energy, and the overall structure of the universe might be fundamentally flawed or incomplete. Such discoveries propel researchers into uncharted territory, where they must devise new theories or refine old ones. This constant reworking of ideas fosters innovation and opens the door to deeper inquiry. For instance, imagine the discovery of galaxies that are far more massive than current models predict. Such a revelation would force scientists to rethink how gravity functions on the largest scales of the universe. It could even lead them to consider the existence of previously unknown forces at play, adding complexity to the already intricate cosmic puzzle. Every new finding, like an additional piece of a grand puzzle, provides further insight into the universe's majestic and mysterious design. These groundbreaking discoveries inevitably spur the development of new observational technologies and methodologies. In the pursuit of understanding these strange cosmic structures, researchers often create novel instruments or innovative techniques to gather more accurate and detailed data. This ongoing cycle of exploration not only enhances our understanding of the universe, but also exemplifies the flexibility and adaptability of the scientific method in response to new evidence. At its core, each unexpected discovery reinforces the idea that science is not a final destination, but an ever-evolving journey. As we continue to unravel the mysteries of the cosmos, we not only push the boundaries of our knowledge, but we also expand the potential for groundbreaking insights that could forever alter our perception of reality and our place within it. One of the most profound concepts in modern cosmology is the theory of the multiverse, suggesting that our universe is merely one of countless others, each with its own set of physical laws, constants, and dimensions. The idea of multiple universes challenges our traditional understanding of reality, opening up a realm of possibilities where each universe could represent a different version of reality. This vast, interconnected web of universes could be infinitely diverse, some of them possibly far more strange and unrecognizable than our own. The multiverse theory offers a new lens through which to view the very nature of existence. It suggests that the universe we observe may only be a small fragment of a much larger, interconnected reality. Anomalies, such as quantum events or unusual cosmic phenomena, hint at the possibility that our universe may be deeply intertwined with others. For example, in quantum mechanics, particles can exist in multiple states until they are observed. This idea gives rise to the possibility of branching realities, where each potential outcome of a decision or event leads to the creation of separate universes in which each possibility is realized. Such phenomena, like particles behaving unpredictably or events occurring that defy logic, could be glimpses into these alternate realities, supporting the idea of the multiverse. The theory is grounded in various branches of theoretical physics, including string theory and inflationary cosmology. String theory proposes that the fundamental building blocks of matter are not points, but rather tiny, vibrating strings. These strings can create complex structures and could give rise to multiple dimensions, each with its own set of physical laws. Inflationary cosmology, on the other hand, suggests that the rapid expansion of the universe in its earliest moments may have created isolated bubbles, each representing a distinct universe with its own unique physical characteristics and temporal evolution. While the connections between these universes remain speculative, the mere possibility of their existence has captured the imagination of scientists and philosophers alike. By challenging our understanding of space, time, and the very fabric of reality, the multiverse theory invites us to consider profound questions about our place in the cosmos and the potential limits of our own universe. It forces us to confront the idea that our universe, as vast and complex as it seems, may be only one piece of a much greater puzzle. As we continue to explore the unknown, we are also confronted with the tantalizing paradox of an edge to the universe, an idea that challenges everything we know about the nature of space and time. Traditionally, when we think of edges, we imagine a boundary, a clear limit where one thing ends and another begins. But the universe, as we understand it, defies this simple conception. Current cosmological models propose that the universe is expanding, but this expansion doesn't imply the existence of a physical boundary or edge where the universe comes to a halt. If we were to try to define such an edge, we would encounter significant problems with our established physical laws, particularly those grounded in Einstein's theory of general relativity. This theory describes how gravity influences the curvature of space-time, shaping the very structure of the universe. The concept of an edge to the universe would challenge the notion of an infinite, ever-expanding cosmos, and could lead to situations where the fabric of space-time behaves in ways we cannot yet predict. The consequences for the laws governing cosmic phenomena such as gravity and light would be profound and far-reaching. In essence, the idea of an edge to the universe if it were even possible, raises fundamental questions about the nature of space itself and forces us to reconsider some of our most deeply held assumptions about the universe's structure and boundaries. As we continue our journey into the unknown, each new discovery brings us one step closer to understanding the vast and mysterious cosmos in which we live. The concept of an edge to the universe is both fascinating and perplexing. It raises profound questions about the limits of existence and what lies beyond the cosmic horizon. For centuries, humanity has wondered whether the universe is finite or infinite, whether it has boundaries that define its edges, or if it stretches endlessly into the unknown. If such an edge exists, it would fundamentally challenge our current understanding of space and time, compelling scientists to rethink basic principles about the behavior of matter, energy, and the laws of physics. An edge might suggest that the universe has a clear and defined boundary, beyond which there is something else, perhaps another realm or another reality. Is there an infinite void stretching beyond the cosmos, or is the universe surrounded by something far stranger and more profound? Such questions could force physicists to confront the very nature of existence and its limitations. The current models of the universe, grounded in the principles of isotropy and homogeneity, assume that physical laws operate uniformly throughout the cosmos. But what if this assumption is wrong, and the universe has a more complex structure than we can even begin to comprehend? In this context, the idea of a cosmic edge also invites exploration into theories like the multiverse. Could it be that our universe is just one of many, each with its own set of physical laws and constants? Such a possibility would mark a radical shift in our understanding of reality itself. Embracing the idea of varying laws of physics across different universes would not only revolutionize the field of theoretical physics, but also open new philosophical doors, urging us to rethink our place in the grand tapestry of existence. The notion of the edge of the universe challenges more than just the foundations of physics. It forces us to question the very nature of reality. What does it mean for something to exist beyond the observable universe? Can we ever hope to understand the true scope of existence? Or are we forever trapped within the limits of our own perception? By expanding the boundaries of observation and theory, scientists could potentially uncover new realms of physics that exist beyond the cosmic horizon. These discoveries might reveal dimensions and forces that are currently unimaginable, offering the key to a unified theory of everything that bridges the gap between the strange, probabilistic world of quantum mechanics and the solid, predictable nature of general relativity. Delving into the universe beyond what we can observe could also provide new insights into the phenomenon of cosmic inflation, the rapid expansion of space just moments after the Big Bang. If we could measure the properties of space beyond the observable universe, we might uncover evidence that supports the idea of a multiverse, suggesting that our universe is just one of many, each governed by its own set of laws. Some universes might operate with entirely different constants, leading to entirely different realities. Such a discovery would profoundly deepen our philosophical understanding of existence, prompting us to reconsider our very nature and place in the cosmos. Ultimately, exploring the cosmos beyond our reach is not merely an academic pursuit. It represents a chance to fundamentally reshape our understanding of reality, space, and time. If scientists could measure phenomena beyond the observable universe, it would not only be a breakthrough in science, it would be a paradigm shift, forcing us to rethink the very fabric of existence. This would push the boundaries of technology and theoretical physics, leading to a new era of discovery that could transform the study of the cosmos into a completely new field of inquiry. We may very well be on the cusp of an age where the questions of the universe that have plagued humanity for millennia are finally answered. The search for answers about the universe's limits is not just a modern endeavor. Throughout history, various cultures and philosophies have grappled with the idea of cosmic boundaries, or the lack thereof. In ancient Mesopotamian cosmologies, for instance, the Earth was depicted as a flat disk surrounded by waters with a firmament above. This model gave a very tangible sense of the universe having an edge. Similarly, many indigenous cultures have viewed the Earth as a defined space, often shaped by mythological narratives that place limits on the known world. In contrast, some schools of thought, particularly within Eastern philosophy, have embraced a notion of boundlessness. Buddhism, for example, perceives the universe as a cyclical and infinite process: birth, death, and rebirth in an endless cycle. In this view, the universe is not confined to an edge, but rather exists in an eternal continuum, where everything is interconnected and interdependent. This concept transcends the material and suggests that the universe does not have a final boundary, nor does it have a definitive end. Western philosophy, too, has evolved its views on the structure of the cosmos. Ancient Greek thinkers like Aristotle proposed a geocentric model where Earth was the center of the universe, with everything revolving around it. This model implied a clear structure and order, but it was later challenged by figures such as Copernicus and Galileo. With the advent of modern science, the idea of an infinite universe began to take hold. The Big Bang Theory, for example, suggests that the universe has been expanding since its inception, without a detectable edge in sight. As our scientific understanding has progressed, concepts such as the multiverse have emerged, suggesting that not only is the universe infinite, but there may be countless other universes as well, each with its own laws of physics. This growing body of knowledge invites us to reconsider our place in the cosmos and encourages us to embrace a vision of the universe that is far more complex, dynamic, and interconnected than we ever imagined. Scientists are currently working on a variety of innovative experiments to push the boundaries of our understanding of the universe. One of the most promising tools in this endeavor has been the Hubble Space Telescope, which has provided a wealth of information about distant galaxies, helping astronomers understand how the universe has expanded since the Big Bang. Its observations have shown that galaxies are moving away from us, which indicates that the universe is still expanding. Another breakthrough in cosmic exploration has come from studying the cosmic microwave background radiation, the faint afterglow of the Big Bang. Satellites like the Wilkinson Microwave Anisotropy Probe, WMAP, and the Planck satellite have created detailed maps of this ancient radiation, revealing tiny temperature fluctuations that correspond to regions of varying density in the early universe. These fluctuations are crucial for understanding how galaxies and large-scale structures formed in the first moments after the Big Bang. The data gathered from these experiments and missions provides compelling evidence for the Big Bang theory, suggesting that the universe is about 13.8 billion years old. But even as we uncover new truths about the origins and evolution of our universe, the concept of its edge remains as elusive as ever, an enduring mystery that continues to captivate the imagination of scientists, philosophers, and thinkers across the world. The search for what lies beyond the observable universe is more than a scientific quest. It is a journey into the unknown, one that promises to reshape our understanding of reality itself. Through a combination of technological advancements and groundbreaking observations, scientists have unraveled some of the most profound mysteries of our universe. One of the most pivotal discoveries stems from the study of supernovae, particularly Type 2a supernovae, which serve as invaluable standard candles for measuring cosmic distances. These stellar explosions, which occur when a massive star reaches the end of its life cycle, have provided astronomers with the tools necessary to gauge the scale of the universe. Through their observations, researchers have made a shocking revelation. The rate at which the universe is expanding is accelerating. This phenomenon, first identified in the late 1990s, is attributed to an enigmatic force known as dark energy, which is thought to constitute roughly 70% of the total energy content of the universe. Although dark energy remains an invisible and elusive presence, its effects on the cosmos are unmistakable. Its influence is most evident in the large-scale structure of the universe, where galaxies and clusters of galaxies are accelerating away from each other, driven by the force of dark energy. Yet, despite its pervasive presence, scientists have yet to directly observe dark energy, which makes its study one of the most compelling and challenging endeavors in modern physics. At the same time, other monumental scientific initiatives, such as those led by the Large Hadron Collider, LHC, and the Laser Interferometer Gravitational Wave Observatory LIGO, continue to probe the fundamental nature of matter, energy, and the very fabric of space-time itself. These high-energy experiments are designed to uncover the deepest secrets of the universe, such as the potential existence of additional dimensions and particles that have yet to be discovered. With each breakthrough, these efforts push the boundaries of human knowledge, sparking a profound curiosity about what lies beyond our observable universe. The convergence of quantum physics and cosmology offers yet another layer to our understanding of the universe. Quantum mechanics, which describes the behavior of the tiniest particles, introduces mind-boggling concepts such as superposition, the idea that particles can exist in multiple states simultaneously until they are observed. This strange and counterintuitive behavior has far-reaching implications, not only for our understanding of subatomic particles, but for the universe as a whole. One of the most captivating ideas to emerge from quantum mechanics is the concept of the multiverse, which suggests that our universe may be only one of countless others, each with its own set of physical laws. The many worlds interpretation of quantum mechanics posits that every quantum event results in a branching of reality, creating an infinite number of parallel universes. In this scenario, each universe may have distinct physical constants, dimensions of time and space, or even entirely different laws of physics. The multiverse theory challenges our traditional singular view of the universe and encourages us to think more expansively about the nature of existence. Cosmological theories, particularly those related to cosmic inflation, further fuel these speculations. Cosmic inflation refers to the rapid expansion that occurred during the first moments of the Big Bang, and some models suggest that this inflationary period could lead to pocket universes that evolve independently from one another, each with its own unique properties. This idea is beautifully consistent with the principles of quantum mechanics, where tiny fluctuations during inflation could have given rise to different regions of space-time, each evolving into its own universe. This intersection of quantum physics and cosmology leads us to ponder questions that defy easy answers. What is the true nature of reality? If multiple universes exist, what does that mean for our place in the cosmos? The more we learn, the more we realize how deeply interconnected the universe is, and how little we may truly understand about its ultimate nature. However, verifying these hypotheses is far from straightforward. One of the most significant challenges facing scientists today is the sheer scale of the universe. The vast distances that separate celestial bodies make it nearly impossible to collect direct empirical data. Light from distant stars, galaxies, and other cosmic phenomena can take millions or even billions of years to reach us, meaning that much of what we study in effect a glimpse into the distant past. As a result, many scientific investigations rely on indirect observations using models and simulations to make sense of the vast and complex cosmos. Moreover, the very nature of the universe's boundaries remains uncertain. Current theories suggest that the observable universe is limited by the distance that light has traveled since the Big Bang, which means that there are regions of space that remain forever beyond our reach. These uncharted territories may harbor galaxies, stars, and even entire regions of space-time that we cannot detect or study directly. As a result, what lies beyond this observable horizon remains a tantalizing mystery, one that scientists can only theorize about. The mysteries surrounding dark matter and dark energy only add to this complexity. While their existence is inferred from their gravitational effects on visible matter, both dark matter and dark energy have yet to be directly observed. These phenomena constitute some of the most perplexing challenges in modern physics, and scientists are still debating their true nature and implications. Constructing experiments to test hypotheses about these elusive substances requires cutting-edge technology and methods, many of which are still in development. As a result, progress in this area is often slow and fraught with uncertainty. Furthermore, the universe's complexity means that even small errors in measurement or interpretation can have significant consequences. Scientists must contend with a host of factors, such as cosmic radiation, gravitational waves, and the interstellar medium, that can obscure or distort their observations. These challenges only underscore the rich, intricate nature of the cosmos and highlight the ongoing need for innovation and refinement in our scientific methods. At the core of much of this research lies the concept of space-time, which merges the three dimensions of space with the dimension of time into a unified four-dimensional continuum. According to Einstein's theory of relativity, massive objects like stars and planets warp the fabric of space-time around them, influencing the motion of other objects nearby. This interaction not only shapes the behavior of individual particles and celestial bodies, but also plays a crucial role in the expansion of the universe itself. Space-time also has profound implications for our understanding of the observable universe. The universe is not static. It is expanding. The observable universe extends about 13.8 billion years into the past, and this expansion is ongoing. However, there are regions of space that are receding from us faster than the speed of light, making them effectively unreachable. This expansion means that there may be vast regions of the cosmos that we will never be able to observe or study, no matter how advanced our technology becomes. The implications of this are staggering. Some physicists propose that the universe may not be the only one that exists. Rather, it could be part of a larger multiverse, in which each universe has its own unique set of physical laws. In this framework, the laws that govern our universe, such as the speed of light, the strength of gravity, or the constants of particle physics, might be vastly different in other universes. These ideas challenge our most fundamental assumptions about reality and raise profound questions about the nature of existence itself. The pursuit of knowledge about the universe is a never-ending journey. As we uncover new layers of understanding, we also find ourselves confronted with even more questions, mysteries, and possibilities. The quest to understand the cosmos is one of the most profound intellectual challenges humanity has ever faced. Yet, despite the obstacles, we continue to push the boundaries of science, eager to explore the vast interconnected tapestry of the universe, one discovery at a time. Space-time, that fabric that intertwines time and the three dimensions of space, has captivated the minds of scientists for generations, but nowhere is its behavior more extreme or its mysteries more profound than near black holes. In these regions, the very nature of reality seems to bend and twist under the influence of the colossal gravitational forces at play. Time itself behaves unpredictably in such environments, with the phenomenon of time dilation providing a glimpse into the strange effects black holes can have on the flow of time. These effects are so intense that they challenge the very fabric of our understanding, hinting at hidden realms that lie beyond our observable universe. It is here, in these uncharted territories, where the usual laws of physics appear to break down entirely. This idea not only enriches our understanding of the cosmos as we know it, but it also sparks our imagination, enticing us with the promise of unknown mysteries that await exploration. As we study these extreme environments, we learn more about the very nature of space and time, pushing the boundaries of what we thought was possible. Then there's the cosmic microwave background radiation, or CMB, a faint, persistent glow that permeates the entire universe, offering us a vital key to understanding the universe's earliest moments. This ancient radiation, which echoes the heat of the universe just 380,000 years after the Big Bang, serves as a window into the infancy of our cosmos. It marks the pivotal moment when the universe, once opaque and dense, began to cool and become transparent, allowing light to travel freely for the first time. The CMB is everywhere, uniform in its distribution, yet within it lies a wealth of information. Tiny, nearly imperceptible fluctuations in temperature are embedded in the radiation, fluctuations that carry the secrets of the universe's earliest structure. These minuscule variations reveal critical insights into the initial density of matter, and by analyzing these patterns, scientists can map out the distribution of galaxies across the universe. This cosmic snapshot is more than just a relic from the past. It holds the key to understanding the ongoing expansion of the universe and its overall geometry. In simpler terms, the patterns we observe in the CMB are like a cosmic blueprint, a map that charts the universe's evolution and current state. But the CMB also allows scientists to probe deeper questions. What is the nature of dark matter, that mysterious substance that does not emit light, but is believed to make up most of the mass in the universe? And what about dark energy, a force that seems to drive the universe's accelerating expansion? These questions, once abstract, are now within the realm of scientific inquiry, with the CMB acting as a guide. The data gathered from studying the CMB suggests something remarkable, that our universe is flat on a grand scale and expanding at an accelerating rate. This revelation has shaken the foundations of previous scientific theories and raised even more intriguing questions about what lies beyond the limits of what we can observe. The CMB, in essence, acts as a cosmic time capsule, offering a glimpse into the fundamental forces that shape the universe as we know it today. It bridges the gap between the past and present, showing us a picture of the universe's edge, and perhaps even beyond it, evoking a sense of wonder about the unknown realms that still await discovery. But the journey to understanding our universe is not a recent development. It has been propelled by centuries of human curiosity. From the earliest days, when ancient civilizations first looked to the heavens, humanity has been entranced by the stars, planets, and the vast expanse of the cosmos. The ancient Greeks were among the first to attempt to unlock the mysteries of the heavens, observing celestial bodies and theorizing about their movements and nature. Their inquiries sparked some of the earliest theories about the structure of the universe, particularly the debate on whether the cosmos was finite or infinite. This thirst for knowledge only grew over time. During the Middle Ages, philosophers like Nicholas Copernicus dared to challenge the prevailing geocentric model of the universe, which placed Earth at the center of everything. His revolutionary heliocentric theory, which proposed that the sun was at the center of our solar system, sparked a paradigm shift that would inspire generations of astronomers and physicists to come. Building on Copernicus's work, thinkers like Johannes Kepler and Galileo Galilei made groundbreaking discoveries that advanced our understanding of planetary motion and the use of telescopes to observe celestial bodies. These advances paved the way for an even more profound exploration of the universe, one that would challenge the very nature of space and time itself. By the 20th century, the advent of modern physics brought forth a seismic shift in our understanding of the universe's structure and boundaries. Albert Einstein's theories of relativity transformed the way scientists viewed space and time, suggesting that the universe was not a static entity but a dynamic, ever-expanding cosmos. Einstein's groundbreaking work forced scientists to confront the question, does the universe have an edge, or does it stretch infinitely in all directions? Further evidence supporting the notion of an ever-expanding universe came from the work of Edwin Hubble, whose observations of distant galaxies revealed that they were moving away from us, indicating that the universe itself was stretching. This discovery forever altered our understanding of the cosmos, confirming that we live in an expanding universe where galaxies drift apart over time. Today, the search for answers continues. Scientists continue to probe the farthest reaches of space, searching for clues that might unlock the secrets of the universe's origins, its fate, and the forces that govern it. Whether through the study of black holes, the CMB, or the ongoing expansion of the cosmos, human curiosity remains the driving force behind our quest for knowledge. And as we push the boundaries of what we can observe, we inch closer to understanding the full extent of the universe, its past, its present, and perhaps its ultimate future. Our quest to understand the universe remains one of humanity's most profound endeavors. Fueled by an insatiable curiosity, we are driven forward by leaps in technology and the expansion of scientific understanding. Today, our exploration of the cosmos is more dynamic and groundbreaking than ever, thanks to innovations like space telescopes, interplanetary missions, and cutting-edge observational tools. These initiatives are continually revealing new phenomena, sparking fresh questions and providing new insights into the very nature of reality itself. Questions that challenge our understanding of fundamental concepts like dark matter, dark energy, and the intricate fabric of space-time. Every discovery offers us a glimpse into the unknown, yet each one also brings with it a new mystery, urging us to look further into the depths of the cosmos. As we explore the farthest reaches of the universe, we also reshape our understanding of what might exist beyond the observable universe, in realms untouched by current technology. Through this delicate interplay of curiosity, exploration, and discovery, humanity's quest for knowledge about the cosmos has only just begun. At the heart of this journey is a multifaceted approach that combines theoretical frameworks, advanced mathematical models, and innovative observational techniques. Researchers use these tools to probe into the depths of space, often venturing far beyond what is visible to the naked eye. One of the most powerful methods at their disposal is mathematical modeling. This approach allows scientists to simulate various conditions of the universe and predict how it might behave under specific circumstances. By grounding these models in well-established theories, such as general relativity and quantum mechanics, scientists can postulate scenarios that extend our understanding beyond the limits of current observation. An especially intriguing area of research is the study of cosmic inflation. This theory posits that the universe underwent an incredibly rapid expansion just after the Big Bang. By examining the aftermath of this expansion, researchers can theorize the existence of regions of space that may forever remain beyond our reach, a concept often referred to as the multiverse. This theory opens the door to the exploration of realms that could operate under completely different physical laws or even new dimensions of reality. Ideas that challenge our current conception of the cosmos and push the boundaries of our understanding even further. In addition to theoretical modeling, astronomers rely on data gathered from a variety of observational techniques. For example, cosmic microwave background radiation, the faint glow left over from the Big Bang, offers critical insights into the universe's early conditions. Similarly, the large-scale distribution of galaxies helps to illuminate the large-scale structure of the universe, while techniques like gravitational lensing reveal clues about the mysterious dark matter and dark energy that make up a significant portion of the cosmos. These observations point to phenomena and structures that remain largely invisible, yet their presence is felt in the way they affect the fabric of space and time itself. The pursuit of understanding cosmic anomalies, such as black holes and dark matter, requires collaboration across disciplines. Theories in cosmology, astrophysics, and even mathematics need to be tested and refined through rigorous discussion and debate. Workshops, conferences, and academic publications are crucial to advancing the field, allowing scientists to share their ideas, challenge one another's findings, and refine models that bring us closer to understanding the mysteries of the universe. This exchange of ideas, often spanning multiple scientific domains, fosters new perspectives and methodologies that are essential for unraveling the most elusive aspects of space and time. Interdisciplinary collaboration plays a central role in tackling the complex challenges posed by cosmic anomalies. The universe is a vast, intricate tapestry woven from threads of many different scientific fields. Physics, astronomy, mathematics, computer science, and even philosophy are all needed to fully comprehend the strange and often paradoxical nature of phenomena such as black holes, dark matter, and cosmic radiation. By drawing on the expertise of scientists from various disciplines, researchers can approach these anomalies from a variety of angles, leading to groundbreaking insights and innovative solutions. One area where such interdisciplinary efforts have been particularly fruitful is in the merging of astrophysics and computer science. As large-scale astronomical surveys produce vast quantities of data, sophisticated algorithms and machine learning methods are increasingly used to sift through this information. These tools help scientists identify patterns, uncover hidden anomalies, and formulate new hypotheses. Without these technological advances, many of the secrets of the universe would remain just that, hidden. Yet with the aid of these powerful computational tools, researchers can glimpse the unseen and begin to piece together the puzzle of our cosmic origins. The collaboration between theoretical physicists and observational astronomers is another cornerstone of this scientific endeavor. As theorists propose new models to explain observed phenomena, their work guides the direction of future observational campaigns. In turn, the real-world observations gathered by astronomers may challenge existing models, leading to a revision of theories and a deeper understanding of the universe's true nature. This back-and-forth exchange between theory and observation drives the scientific process forward, ensuring that each step taken brings us closer to unlocking the universe's most profound secrets. Through these collaborative efforts, spanning across disciplines and incorporating diverse methods, researchers continue to expand our understanding of the cosmos, Each breakthrough, each new discovery, contributes to a richer, more complex picture of the universe. As we look beyond the observable, we inch ever closer to the answers to questions that have puzzled humanity for millennia, and in doing so, we continue to redefine what we know about the very nature of existence itself. Interdisciplinary dialogue extends far beyond the confines of the hard sciences, especially when humanity begins to grapple with the profound philosophical questions arising from cosmic discoveries. The nature of space-time, existence itself, and the mysteries of the universe are concepts that are not only of interest to physicists and astronomers, but also deeply entwined with philosophical thought. Insights from philosophy provide a crucial framework for considering the ethical dilemmas and societal impacts that inevitably accompany the continued exploration of the cosmos. As we venture further into the vast unknown, the merging of knowledge from different disciplines will inevitably illuminate our path forward, allowing even the most complex cosmic anomalies to be more comprehensible and accessible to curious minds. In this vast journey of discovery, imagination plays a vital role, often acting as the catalyst that propels scientific inquiry. As researchers explore the uncharted realms of the cosmos, they frequently encounter phenomena that have not yet been observed or fully understood. In such instances, it is imagination that allows scientists to hypothesize what might exist beyond our current limits of comprehension. The concept of black holes is a prime example. Once relegated to the domain of theoretical speculation, the idea was given structure and credibility through imaginative frameworks that later provided the foundation for observational verification. Without such imaginative foresight, the confirmation of black holes as real astronomical entities might have been postponed, perhaps indefinitely. Imagination is not merely a companion to scientific methodology. It is, in many ways, an indispensable component of the entire process of discovery. It helps scientists envision experiments, design technologies, and plan strategies to probe the universe's most perplexing phenomena. A striking example of this is the Hubble Space Telescope. In its early days, the idea of capturing detailed images of distant galaxies was little more than a dream. However, through imaginative planning and the vision of scientists and engineers, the telescope became a reality, profoundly altering our understanding of the universe. The images it sent back have revealed stunning details about the structure of galaxies, stars, and planets, transforming our view of the cosmos. Beyond the realm of individual breakthroughs, imagination fosters collaboration across scientific disciplines, encouraging problem-solving approaches that transcend traditional boundaries. The exploration of space, for instance, requires not only the expertise of astrophysicists, but also the contributions of engineers, artists, and even philosophers. Each discipline brings its own unique perspective and creativity to the table, enhancing the collective ability to solve complex problems in innovative ways. Whether it's designing a new spacecraft or conceptualizing how we might interact with extraterrestrial life, the fusion of different perspectives often results in solutions that would otherwise remain undiscovered. As humanity continues to push into the vast, uncharted territories of the universe, it becomes clear that imagination is not just an accessory to rigorous scientific research. It is a cornerstone that drives the entire process forward. This imaginative spirit helps us stretch the boundaries of what is possible, pushing us to explore realms of knowledge that were once considered inconceivable. Among the most audacious and intriguing ideas to emerge in the field of cosmology is the theory of the multiverse. According to this theory, our universe could be just one of countless others, each with its own set of physical laws and dimensions. Some physicists suggest that our universe may be but a single bubble within a vast cosmic foam, with each bubble representing an entirely different universe. This concept fundamentally challenges our traditional understanding of reality and invites us to reconsider what it means for something to exist. An even more unconventional theory posits the idea of an infinite, ever-expanding universe that might not have a defined boundary at all. In this model, space itself could curve back on itself, much like the surface of a balloon. If one were to travel far enough in one direction, they might eventually return to the point where they started, suggesting a universe without edges or limits. Such a model, if proven true, would radically alter our understanding of cosmology, introducing the possibility of infinite space and time. Another theory that has captivated the imagination of researchers is the holographic principle, which suggests that all the information within our three-dimensional universe could be encoded on a two-dimensional surface. This would mean that our perception of the universe as a three-dimensional reality is an illusion, a projection of sorts, created by information stored on a distant, higher-dimensional surface. If true, this theory would blur the lines between what we perceive as reality and what might be a much deeper, more complex structure beneath the surface. Lastly, the no-boundary proposal by renowned physicist Stephen Hawking offers a radically different perspective on the universe's origins. According to this idea, the universe is finite but unbounded. Instead of having edges or singularities, the universe might form a smooth, self-contained structure that extends infinitely without any clear boundary. This concept challenges conventional notions of the Big Bang and suggests that when we trace the universe back to its origins, we would encounter a seamless continuum, not a point of singularity. Each of these theories opens new avenues for exploring the deepest questions of existence. They encourage us to think beyond the limits of conventional science, pushing us to consider the nature of reality in ways that were once unthinkable. At the intersection of these scientific explorations lies a fundamental philosophical question. What does it mean to exist? Philosophical perspectives play a crucial role in shaping the ways scientists approach cosmic anomalies and phenomena at the edges of the observable universe. Some philosophies assert that existence is based on observable phenomena, while others argue that it relies on theoretical frameworks to explain what cannot be directly measured. This divide challenges scientists to consider not just empirical data, but also the underlying principles that govern the very fabric of reality. The investigation into anomalies, unexpected phenomena, or mysterious occurrences in the cosmos requires more than just the collection of data. It demands a theoretical framework against which that data can be interpreted. As philosophers like Karl Popper have argued, the importance of falsifiability in scientific theories cannot be overstated. According to Popper, our understanding of natural laws is always provisional, subject to change as new observations emerge. This insight invites an ongoing interaction between philosophical inquiry and scientific methodology, pushing researchers to refine their theories as new findings come to light. Various philosophical schools of thought offer unique perspectives on the nature of existence and how we might approach the unknown. For example, existentialist philosophy encourages scientists to reflect on the broader implications of discovering new phenomena, questioning what such findings reveal about the human condition and our place in the universe. Meanwhile, a realist perspective focuses on the belief that the universe exists independently of our observations, motivating empirical research aimed at uncovering hidden truths. These philosophical frameworks are not merely academic. They influence every step of the scientific process, from data collection to hypothesis testing and the interpretation of extraordinary findings. As scientists examine phenomena such as cosmic microwave background radiation or gravitational waves, these philosophical perspectives provide a larger context, prompting deeper inquiries into the nature of space, time, the multiverse, and the very fabric of reality itself. In this way, the interaction between philosophy and science does more than illuminate the mysteries of the universe. It also inspires a continual re-evaluation of our understanding of existence itself. The discovery of intelligent life, either beyond or even within the observable universe, would have profound implications for our worldview. Such a revelation would challenge humanity's place in the cosmos, forcing us to reconsider what it means to be human and how we relate to other potential life forms. The knowledge that we are not alone would spark intense curiosity about the cultures, technologies, and philosophies of these intelligent beings. This might not only enrich our understanding of life and consciousness, but could also fuel technological and scientific advancements. Communication with extraterrestrial life, for instance, could drive innovations in space travel, telecommunications, and artificial intelligence. If these beings possess technologies far more advanced than our own, Humanity might seek to understand their methods and perhaps even exchange ideas, propelling us to new heights of innovation. In the end, the pursuit of knowledge about the universe and the potential discoveries that lie ahead reminds us that our understanding of existence is constantly evolving, shaped by both scientific inquiry and philosophical contemplation. As we continue to reach for the stars, it is the fusion of these two forces that will ultimately guide us toward new frontiers. Furthermore, the discovery of intelligent life capable of long-distance communication could prompt a profound reevaluation of our ethical responsibilities in the realm of interstellar relations. How would we engage with beings whose social structures, ethical frameworks, and even biological makeups might differ radically from our own? This discovery could force humanity to reconsider the very principles that guide our interactions not just on Earth, but across the cosmos. As we explore further beyond our solar system, the emphasis on peaceful exploration and cooperation could shift from an idealistic goal to a necessity. These principles would become paramount, potentially guiding the very way we approach space exploration and interspecies communication. The search for common ground between us and extraterrestrial beings, if they exist, could become the cornerstone of a new era of cosmic diplomacy. Such a scenario might also have far-reaching effects on our own planetary cooperation. A shared focus on peaceful interstellar exploration could catalyze a deeper sense of unity among the nations of Earth, encouraging us to collaborate rather than compete. Nations might set aside their earthly disputes in favor of joint space initiatives, leading to a more harmonious and cooperative global community. However, this newfound cooperation would not be without risks. The potential for pandemics arising from interactions with extraterrestrial life could create a significant biological threat. The notion of biology transcending planetary boundaries reveals the very real dangers of cross-contamination, whether from Earth to distant worlds or vice versa. Therefore, understanding and preparing for these risks would be crucial. As humanity grapples with these monumental revelations, the broader implications for our understanding of life itself could lead to a philosophical renaissance, one that prompts a deep existential reflection on our place in the universe. The journey to comprehend intelligent life beyond our planet would stretch the limits of human imagination. It would not only expand the boundaries of science, but also force us to confront our own assumptions and beliefs about existence. This intellectual and philosophical shift could influence every corner of human thought, sparking new discussions on life, purpose, and responsibility, both on Earth and in the broader cosmos. In many ways, this journey would parallel the ways in which science fiction narratives have shaped public understanding of the universe. These imaginative tales often bridge the gap between complex scientific concepts and the general public, making extraordinary ideas more accessible. Writers who explore the possibilities of black holes, wormholes, or alien civilizations often ground their stories in real scientific theories, helping to demystify these concepts for a wider audience. Take, for example, the concept of a black hole. What was once a deeply abstract idea rooted in mathematical models and theoretical physics is now a common subject of fascination in popular culture. Through books, movies, and television shows, black holes have moved from the realm of advanced astrophysics to the mainstream, with their dramatic implications serving as a powerful way to engage the public's imagination. This storytelling, in turn, invites people to ponder the mysteries of the universe, sparking curiosity and intellectual engagement. Furthermore, science fiction does more than just tell compelling stories. It serves as a platform for speculative discussions about the feasibility and consequences of cosmic anomalies. By exploring scenarios where time travel, interdimensional travel, or encounters with extraterrestrial civilizations are possible, these narratives open up a realm of questions that challenge our understanding of space, time, and reality. They encourage audiences to think critically about the limits of scientific knowledge and the boundaries of human potential. Such stories can also inspire viewers to explore the underlying science, deepening their interest in fields like cosmology and physics. The creative imagination ignited by science fiction narratives can, in turn, foster an environment in which new scientific ideas flourish, bridging the gap between established knowledge and the uncharted territory of what is yet to be discovered. Moreover, the emotional responses elicited by these stories often reflect broader societal hopes and fears, particularly regarding technology and the unknown. For instance, depictions of extraterrestrial life often stir a range of emotions, from excitement about the possibility of new civilizations to fear of potential conflict or the threat of invasion. These responses inevitably shape the public discourse surrounding scientific inquiries, such as the search for extraterrestrial intelligence or the study of black holes. As large audiences become emotionally invested in these narratives, they begin to form opinions that can have a tangible impact on funding, research priorities, and educational initiatives in science and technology. Ultimately, science fiction plays a dual role. It entertains and educates. It provides a framework for understanding complex scientific ideas, contextualizing them within the broader narrative of human existence. This unique interplay between imagination and scientific inquiry ensures that, as our understanding of the universe expands, so too does the public's perception of it. The ongoing dialogue between wonder and skepticism propels humanity forward, maintaining an unbroken cycle of intrigue, discovery, and exploration. One such cosmic mystery is gravitational lensing, a phenomenon that acts like a cosmic magnifying glass. Predicted by Albert Einstein's theory of general relativity, gravitational lensing occurs when a massive object, such as a galaxy or a black hole, intervenes between an observer and a distant light source. The gravitational field of the foreground object distorts the fabric of space-time, bending the light from the background source around it. This distortion creates multiple images of the same object, warping its appearance or even amplifying its brightness. This phenomenon has proven invaluable to astronomers, offering a unique way to observe objects that would otherwise be too faint or distant to detect. But gravitational lensing does more than simply enhance our view of the universe. It opens a portal to detecting cosmic anomalies that would be invisible through direct observation. One of the most fascinating applications of this phenomenon is its role in uncovering dark matter. Dark matter, which makes up about 27% of the universe, is notoriously elusive. It doesn't emit, absorb, or reflect light, rendering it completely imperceptible to traditional observational methods. Despite this, scientists can infer its existence by observing the gravitational effects it has on visible matter. By studying the light-bending patterns caused by gravitational lenses, astronomers can map the distribution of dark matter in galaxies, galaxy clusters, and even across the vast expanses of the intergalactic medium. Through this process, they are able to reveal hidden structures in the cosmos that would otherwise remain unseen, offering new insights into one of the most enigmatic components of the universe. Gravitational lensing is a phenomenon that allows us to peer into the ancient past of the universe. Through the bending of light caused by massive objects like galaxies and black holes, distant and long-forgotten galaxies are revealed, offering us a glimpse into a time when the universe was still in its formative stages. These galaxies, often so far removed that their light has been traveling towards us for billions of years, appear as faint whispers of what once was. The immense distance between us and these cosmic objects makes their light difficult to detect under normal circumstances. However, when gravitational lensing occurs, it acts as a magnifying glass, concentrating their light and making their faint features detectable. This process not only enables astronomers to examine the formation and evolution of galaxies, but also allows them to study the intricate details of their composition and the conditions under which they came into being. These observations offer a window into a past we could never directly observe, helping us understand how the building blocks of the universe formed and evolved over time. Moreover, gravitational lensing holds the potential to uncover hidden phenomena, such as the presence of supermassive black holes at the centers of galaxies. These black holes are often elusive, their immense gravitational pull keeping them obscured by the surrounding galaxy's light. But through the lensing effect, scientists can infer their existence. By analyzing the way light behaves as it passes through or around these cosmic giants, astronomers can study their properties. shedding light on some of the most mysterious and powerful forces in the universe. Gravitational lensing, then, is not merely an observational tool. It serves as a cosmic gateway, revealing the intricate structures and phenomena that might otherwise remain hidden. It challenges our understanding of cosmic forces and the laws that govern them, providing insights that redefine our comprehension of the universe's vast and often bewildering complexity. However, while the mysteries of the universe beckon, scientists must tread carefully, especially when exploring speculative theories in cosmology. These ideas, though often exciting and thought-provoking, can be riddled with pitfalls. One significant risk is the allure of conclusions that lack sufficient empirical support. Speculative theories can sound fascinating, but without solid evidence, they remain little more than intellectual curiosity. Relying on such theories can be tempting, but it risks creating a fragile foundation for our understanding of the cosmos, one built not on facts, but on untested assumptions. Another concern is that speculation can overshadow well-established scientific knowledge. While the unknown is undoubtedly intriguing and worth exploring, excessive focus on unproven theories can divert resources and attention away from the models and ideas that have proven effective. This imbalance could slow progress on key cosmic mysteries like dark matter and dark energy, phenomena that are both observable and grounded in rigorous research. Unproven ideas, while captivating, could generate a false sense of certainty, distracting from what we already know and from the observable phenomena that demand our focus. Furthermore, speculative theories can complicate the public communication of science. When scientists present ideas that are far removed from current understanding, it can create confusion. The public may struggle to distinguish between what is supported by evidence and what remains hypothetical, leading to skepticism and misunderstandings about the nature of scientific inquiry. The pursuit of theories without empirical backing can undermine trust in science, turning it from a source of knowledge into an arena of endless speculation. Speculation also has the potential to mislead the scientific community itself. While such theories can generate excitement and attract funding, they can also create a cycle of chasing ideas that may never produce concrete results. This diversion of focus can stall critical research, preventing us from pursuing more fruitful avenues of discovery in fields where concrete evidence is within reach. In the quest to understand the universe, a balanced approach is essential. We must embrace the excitement of speculation, but always anchor our understanding in empirical evidence. Only then can we truly unlock the secrets of the cosmos without losing sight of the rigor that makes science such a powerful tool for discovery. Anomalies, those unexpected deviations from established patterns, are perhaps one of the most profound catalysts for scientific advancement. When the universe behaves in ways we cannot predict, it forces us to rethink our most cherished theories and models. These surprises provide invaluable opportunities to explore new explanations, to question existing paradigms, and even to venture into entirely new realms of knowledge. The discovery of dark matter and dark energy provides a striking example of how anomalies can radically alter our understanding. Both were identified not by direct observation, but by their effects on the motion of galaxies and the expansion of the universe. Dark matter, an invisible substance that does not emit light or energy, constitutes a significant portion of the universe's mass, yet it eludes direct detection. Similarly, dark energy, the mysterious force driving the accelerated expansion of the universe, remains one of the greatest puzzles of modern physics. These phenomena challenge the foundations of our knowledge, suggesting that the universe is far more complex than we previously thought, and revealing the limitations of our current understanding. Such discoveries are not isolated. Anomalies in the behavior of quantum particles have also forced us to reconsider the very nature of reality. Quantum mechanics reveals a strange and unpredictable world where particles can exist in multiple states at once or become entangled across vast distances. These phenomena have prompted philosophers and scientists alike to ask profound questions about the nature of consciousness, the role of the observer in shaping reality, and the possibility of parallel dimensions. These anomalies push the boundaries of science and philosophy, inviting us to think beyond the confines of what we once thought possible. At their core, anomalies remind us that our understanding of the universe is not fixed. It is a constantly evolving journey, one that requires us to embrace the unexpected and the unknown. These surprises open new doors of exploration, encouraging fresh perspectives and driving us to rethink our place in the cosmos. Each anomaly challenges us to reconsider not only the physical laws that govern the universe, but also the very nature of existence itself. Human beings, remarkable in many ways, are still limited in how we perceive the cosmos. Our eyes are adapted to see only a narrow band of the electromagnetic spectrum, specifically visible light. This limitation means that we miss vast swaths of the universe, including the heat signatures of distant stars and the ultraviolet radiation emitted by young galaxies. There is an entire universe of phenomena that lie beyond our natural vision, hidden from our sight. Yet this limitation is not the end of the story. It only serves to deepen the mystery, reminding us that the universe is far richer and more complex than we can ever fully perceive. Our sensory perception is fundamentally designed to help us navigate and survive within the confines of our terrestrial environment. It is fine-tuned for immediate, close-range interactions necessary for daily life on Earth, rather than for contemplating the vast expanses of the cosmos. The sensory systems we rely on were shaped by evolution to focus on survival, with particular emphasis on understanding our surroundings at a human scale. Our depth perception and the ability to judge distances, for instance, are calibrated for the relatively small, earthbound spaces we inhabit. However, when we turn our gaze outward to the cosmos, we are immediately confronted with a scale that is beyond our natural comprehension. The distances between celestial bodies are so immense that they stretch the limits of our understanding of space and time. Light from the furthest reaches of the universe can take billions of years to reach us. The scale of time itself becomes a different concept altogether, creating a profound disconnection between the lives we lead on Earth and the cosmic scale in which galaxies form, evolve, and ultimately fade into the darkness. This profound dissonance between the timeframes we are familiar with and the timeframes of the universe forces us to rethink what it means to truly experience time. It challenges us to expand our frame of reference, asking us to see the universe not just as a collection of distant stars, but as a vast, intricate web of events unfolding across eons. Yet our perception extends far beyond just the visual. Our auditory senses, for example, are adapted to detect sounds within a specific frequency range. The cosmic symphonies that play out in electromagnetic waves, the whispers of energy from stars and planets, are all outside the spectrum of human hearing. While we might imagine the universe as a silent void, in truth, it hums with activity, its very essence vibrating at frequencies beyond our perception. We are also acutely aware of the effects of gravity and movement. We feel the weight of the Earth on our feet, the pull of the moon, and the oscillations caused by the Earth's rotation. But these feelings do not give us access to the microscopic subatomic interactions that govern the universe on the smallest scales. The quantum world, with its particles darting in and out of existence, remains largely inaccessible to our senses. It exists beyond the realm of what we can directly perceive, demanding that we turn to technology for insight into this invisible world. Technological advancements have significantly expanded our ability to explore the universe beyond the biological limits of our senses. Tools like radio telescopes, infrared cameras, and ultraviolet detectors allow us to see the cosmos in ways that go far, far beyond the capabilities of the human eye. These instruments translate invisible wavelengths into forms that we can understand, opening up entire new realms of exploration. With the help of these technologies, we are no longer constrained by the narrow bandwidth of visible light. Instead, we can tap into the broader electromagnetic spectrum. This ability to detect a wide range of radiation allows us to observe objects and phenomena that are otherwise invisible, from the inner workings of black holes to the formation of galaxies. However, despite these breakthroughs, the tools at our disposal are still far from perfect. The current state of technology, while incredibly advanced, has its limitations. The vast majority of our observations still rely heavily on visible light, the only form of electromagnetic radiation detectable by the human eye. Although immense progress has been made in optics and imaging, allowing us to capture stunning images of distant galaxies and nebulae. This focus on visible phenomena restricts our understanding of the many other cosmic processes occurring in other wavelengths. Beyond visible light, other forms of radiation, such as radio waves, infrared, ultraviolet, X-rays, and gamma rays, offer entirely new perspectives on the universe. For example, radio waves reveal the hidden structures of galaxies, unveiling secrets that are not visible through optical telescopes. X-rays, on the other hand, allow us to observe the violent processes that occur around black holes and neutron stars, where matter is heated to unimaginable temperatures. These wavelengths can tell us about the most extreme environments in the universe. Yet, we have only just begun to scratch the surface of what is possible. Despite the potential of these other forms of electromagnetic radiation, the instruments we use to detect them remain limited. Many of these tools lack the sensitivity necessary to fully capture the subtle details of distant objects, and we are still restricted by the challenges of launching satellites that can operate across these various wavelengths. Even when we can collect data from these other regions of the electromagnetic spectrum, the sheer volume of information often overwhelms our ability to process and analyze it. In recent years, advanced data analytics and machine learning have begun to bridge this gap, offering new ways to interpret and manage complex data sets. Yet, the pace of technological advancement often struggles to keep up with the ambitious goals set by the space exploration community. The limitations of our current instruments and the infrastructure needed to support them are significant challenges. As a result, many missions continue to focus on well-established, visible phenomena, while other areas of potential discovery remain underexplored. This imbalance in priorities is often driven by funding constraints or political considerations, which dictate which projects receive attention and which are left on the shelf. The prioritization of some missions over others can sometimes result in the neglect of critical, albeit more elusive, aspects of the universe. By expanding our technological capabilities to encompass a wider range of wavelengths and phenomena, we open the door to revolutionary discoveries about the very nature of existence. If we can develop the means to study the universe in more detail, we may uncover answers to fundamental questions that have eluded us for centuries. Mathematical models play a central role in helping us understand the universe. They offer frameworks that allow us to quantify and analyze the complexities of the cosmos. Yet, these models are not without their limitations. The assumptions and simplifications that go into their construction can sometimes lead them astray. When scientists build models, they often rely on educated guesses about certain properties or conditions, especially when faced with phenomena that cannot be directly observed. For example, in the case of dark energy, which is thought to be responsible for the accelerated expansion of the universe, current models assume a constant energy density throughout space. However, if dark energy behaves differently than we expect, our models could fail to reflect the true nature of cosmic expansion. Additionally, the vast expanse of the universe is filled with unknowns. Dark matter, for example, is another mysterious element that remains largely invisible to our instruments. If mathematical models are built on incomplete or incorrect assumptions about dark matter, they will not accurately represent the structure and dynamics of the universe. If dark matter interacts with ordinary matter in ways that we have yet to discover, our models will be severely skewed, leading to flawed predictions about the formation of galaxies and the large-scale structure of the cosmos. As we push the boundaries of our understanding, it becomes clear that our current models are only partial representations of a much grander, more complex reality. The universe is vast and mysterious, and the more we learn, the more we realize how much we have yet to understand. With continued advancements in technology, data analysis, and theoretical modeling, we may one day uncover the answers to some of the most profound questions of existence. Until then, we continue to explore, question, and refine our understanding of the universe, one discovery at a time. Mathematical constructs, deeply intertwined with our observational limitations, present both opportunities and constraints in our understanding of the universe. Often, models are built upon the data we gather from our immediate observations or calculations, but these observations are inherently limited. The universe operates on scales and within realms. like the quantum level or beyond the observable universe, that challenge the very foundations of our mathematical frameworks. It's within these unexplored domains that our current mathematical tools may fail to deliver a comprehensive picture of reality. Take, for example, concepts like string theory or the multiverse, which challenge not only our understanding, but also the boundaries of mathematics itself. These ideas suggest that the mathematics we use might only skim the surface, hinting at deeper, more complex truths that lie just beyond our reach. They illuminate the dynamic relationship between what we observe, the mathematical formulations we employ, and the ultimate, often elusive reality of the cosmos. This reminds us that what we can perceive is just a fraction of the whole picture. What lies beyond is far more intricate than we can imagine. As the scientific community ventures further into the mysteries of the universe, especially around the edges of what we can observe, there's a growing recognition of the intellectual limits we face. The vast unknowns that lie beyond the observable universe continue to expand, urging a more humble and collaborative approach to exploration. This acknowledgement of our limitations propels a culture of openness, where physicists, astronomers, and cosmologists work together to share ideas and formulate new theories. Rigorous peer review ensures that any findings that enter the scientific canon have been carefully scrutinized, refined, and tested against reality. In an effort to close the gaps in our knowledge, scientists often take an interdisciplinary approach, combining insights from mathematics, astrophysics, computer science, and other fields. For example, advanced simulations can help visualize cosmic phenomena that would otherwise remain invisible to the naked eye, offering us a glimpse into the underlying workings of the universe. Models based on the principles of general relativity and quantum mechanics are constantly evolving, being tested and modified to better reflect the universe's complexities. These evolving models help scientists grapple with difficult-to-understand concepts like dark matter and dark energy, both fundamental to our understanding of the universe's structure, yet still largely elusive. Instrumental to these discoveries are observational tools such as the Hubble Space Telescope and the upcoming James Webb Space Telescope. These instruments provide crucial data, expanding our comprehension of the cosmos and helping bridge the gap between known and unknown. They not only assist in refining existing knowledge, but also prompt new questions and hypotheses, steering us toward deeper exploration. Scientists frequently acknowledge that many phenomena in the universe are inherently difficult to measure directly. This is why indirect methods of observation, such as studying cosmic microwave background radiation or detecting gravitational waves, play such an important role in modern astronomy. Public engagement and citizen science initiatives further enrich the journey of discovery. By involving the public, scientists foster a collective curiosity that transcends the academic realm and taps into a universal desire to understand our place in the universe. Sharing findings and theories with the wider public turns the quest for knowledge into a collective endeavor, reminding us that science is not merely an academic pursuit, but a shared human longing to connect with the cosmos. Recognizing the gaps in our understanding of the universe is a vital step in the scientific process. These gaps serve as guides, pointing researchers toward the unknown territories where new discoveries wait. By embracing what we do not yet know, scientists can ask more precise, targeted questions that direct their investigation to areas requiring further exploration. This process not only fuels curiosity, but also fosters innovation, as researchers develop new tools and methodologies to probe the depths of the universe. The universe is vast, complex, and filled with phenomena that often challenge our current models and theories. Take, for example, dark matter and dark energy, both of which account for approximately 95% of the universe, yet remain largely mysterious. Their existence stretches the limits of our understanding and reshapes our perception of the cosmos. By admitting the vastness of the unknown, scientists open themselves to collaboration and interdisciplinary research, often leading to breakthroughs that push the boundaries of both knowledge and technology. This openness to uncertainty and collaboration fosters a scientific culture marked by humility and the recognition that knowledge is always evolving. In such an environment, questioning established theories is not only encouraged, but essential. When researchers are willing to confront uncertainty, they often uncover unexpected results that radically reshape our understanding. These serendipitous discoveries challenge existing paradigms and lead to more refined models that bring us closer to understanding the true nature of the universe. Acknowledging what we do not know is just as important as celebrating what we have already discovered. It propels us forward, igniting a passion for exploration and discovery that has been a driving force behind human progress for centuries. As scientists continue to explore the cosmos, peeling back the layers of mystery, they uncover insights that illuminate not only the universe's story, but also our connection to it. The exploration of anomalies, those unexpected and unexplained phenomena, often serves as a catalyst for scientific advancement. When scientists encounter observations that defy existing models, it sparks a deeper examination of the foundational principles that shape our understanding of the universe. These anomalies often lead to groundbreaking breakthroughs, as was the case with the development of quantum mechanics and the theory of relativity. For example, the peculiar behavior of galaxies has led to the hypothesis that dark matter, an invisible substance, makes up most of the universe's mass. This concept has reshaped the way we view cosmology and forced a rethinking of the universe's structure. Anomalies, like this one, prompt a closer look at what we thought we knew, encouraging the development of new theories and models that better account for the complexities of the universe. Throughout history, significant scientific breakthroughs have arisen from such moments of anomaly. When scientists are willing to embrace the unknown and question established frameworks, they create space for discovery. This process fosters a culture of critical thinking where questioning accepted truths is not just allowed, but actively encouraged. By embracing uncertainty, we find ourselves standing at the threshold of new knowledge, poised to unlock the next great mystery of the cosmos. The search for anomalies in the universe often reveals the limitations of the tools and methodologies currently at our disposal. As scientists work to refine their instruments and techniques in response to these expected phenomena, they don't merely revise their understanding of specific occurrences. They also contribute to the advancement of the scientific toolkit itself. This ongoing process of refinement can spark technological breakthroughs and inspire new experimental approaches that benefit multiple fields of study. Anomalies serve as a reminder that scientific paradigms are not static. They are subject to revision in light of new evidence. The evolution of science is rooted in our willingness to confront the unknown and question established ideas. In many ways, the pursuit of the unexpected is intrinsic to humanity's quest for knowledge, urging us forward by showing that each discovery is a stepping stone to a deeper understanding of reality itself. To truly engage with cosmic anomalies, a delicate balance between skepticism and curiosity is essential. Both of these qualities play critical roles in advancing our comprehension of the universe. Skepticism acts as a safeguard, providing a rigorous filter that helps scientists critically assess claims about unusual phenomena. The cosmos is home to a multitude of extraordinary events, black holes, gamma-ray bursts, and more. Jumping to conclusions too quickly can lead to misinterpretations and the proliferation of unfounded theories. Skepticism allows researchers to scrutinize evidence carefully, ensuring that their conclusions are based on observable and repeatable data, rather than mere speculation. At the same time, curiosity fuels the exploratory spirit that is fundamental to scientific discovery. The universe is inherently mysterious, filled with phenomena that challenge our current understanding of physics and cosmology. Curiosity compels scientists to ask bold questions, seek out fresh ideas, and think beyond conventional frameworks. It is this inquisitive nature that drives researchers to investigate anomalies like fast radio bursts or gravitational waves, phenomena that might provide new insights into the very workings of reality itself. By blending skepticism with curiosity, scientists foster an environment in which knowledge can thrive. This combination ensures that hypotheses are rigorously tested, while still leaving room for the possibility that nature might reveal surprises that force us to revise our understanding. Each cosmic anomaly has the potential to reshape our view of the universe, but only if we approach them with an open mind, tempered by critical thinking. In this sense, the dynamic interplay between skepticism and curiosity is not just an academic pursuit. It reflects a broader philosophy of science. This approach allows humanity to challenge assumptions, refine knowledge, and push the boundaries of what is possible in our quest to understand the cosmos. Each new discovery builds on the last, drawing us deeper into the universe's enigmatic embrace. Infinity is another profound concept that plays a critical role in our understanding of the universe. Deeply intertwined with both cosmology and mathematics, infinity presents us with a multitude of challenges to our intuitive grasp of space and structure. When we think about the universe, the notion of infinity often arises. It forces us to confront the idea of a cosmos without limits, and in doing so, it opens up a host of questions. If the universe is infinite, what does that mean for the distribution of galaxies, the formation of cosmic structures, and even the very laws of physics themselves? The concept of infinity also introduces paradoxes that strain our traditional scientific models. For instance, if the universe is infinite, does that imply there are infinite copies of ourselves scattered across distant regions of space? Ideas like these invite discussions that push the boundaries of our current scientific understanding. Infinity encourages us to think beyond the observable universe, the realm that we can detect and measure. Our scientific models, grounded in empirical observation, struggle to account for phenomena that lie outside of this limited scope, as infinity challenges the very foundation of our ability to confirm theories. Moreover, infinity influences our understanding of some of the universe's most enigmatic phenomena, such as black holes and the Big Bang. These concepts often present singularities, places where traditional physics breaks down and where mathematical models are forced to grapple with infinite values or behaviors that seem counterintuitive. In these instances, we are reminded that our current models, while powerful, may not capture every aspect of an infinite universe. The complexities of infinity underscore the limitations of our existing frameworks, pushing us toward new and more comprehensive theories. The relationship between infinity and the universe also invites philosophical contemplation about the nature of existence itself. If our universe is part of a larger infinite multiverse, could there be other realities that follow entirely different laws of nature? This tantalizing possibility encourages both scientists and philosophers to delve deeper into the mysteries of cosmic structure, prompting us to consider infinity not just as a mathematical concept, but as a window into understanding the very essence of reality. The unrelenting pursuit to comprehend what lies beyond the observable universe serves as an enduring source of inspiration for future generations of scientists. As we gaze into the cosmos, we are confronted with a vast tapestry of stars, galaxies, and unsolved mysteries that stretch far beyond the limits of our current understanding. This boundless expanse ignites curiosity, prompting young minds to question the fundamental nature of reality and their place within it. As they learn about ideas such as cosmic inflation, an idea suggesting that our universe might be just one of many in an even larger multiverse, their imaginations are freed to explore possibilities that challenge the very limits of our knowledge. This quest for understanding, fueled by both skepticism and curiosity, ensures that humanity's journey to unravel the mysteries of the cosmos will continue, pushing us ever closer to the truth about the universe we inhabit. The pursuit of knowledge in this vast and mysterious realm often sparks collaboration across disciplines, uniting fields such as physics, astronomy, and philosophy. This intersection of ideas not only deepens our understanding, but also drives innovation, pushing the boundaries of what we know. For children and young adults, the stories of great thinkers, individuals who dared to challenge conventional wisdom, often ignite a passion for discovery. Figures like Albert Einstein and Stephen Hawking have become iconic, embodying the power of curiosity, creativity, and scientific rigor. Their lives serve as inspirational milestones, illustrating that bold questions and unconventional thinking can lead to profound insights into the workings of the universe. Engaging with concepts like dark matter and dark energy serves to fuel young minds, sparking their imagination and laying the foundation for future breakthroughs. As they dive deeper into these enigmatic phenomena, they not only build on existing knowledge, but also cultivate essential skills such as critical thinking, problem solving, and resilience. These are the tools that future scientists will need as they confront the unknown. The process of constructing hypotheses, designing experiments, and analyzing intricate data fosters a mindset that values persistence, adaptability, and open-mindedness, qualities that are not just vital in the lab, but in every facet of life. In essence, the exploration of the universe's uncharted territories is not merely about accumulating facts. It is about nurturing a culture of curiosity and inquiry. By championing the importance of exploration, we empower young scientists to carry the torch of discovery, ensuring that the spirit of questioning and wonder endures. This process encourages them to pursue answers to questions that have not yet been posed, and to imagine a future where the cosmos holds even more mysteries than we can currently comprehend. Speculation has long been a powerful engine of scientific progress, often sparking groundbreaking discoveries in areas that were once considered purely theoretical. A key example of this comes from the field of atomic theory, where early thinkers like John Dalton and Dmitri Mendeleev proposed models to explain and categorize the elements, long before technology could provide the necessary evidence to confirm their ideas. Mendeleev, in particular, devised the periodic table, predicting the existence and properties of elements that had not yet been discovered. His audacious predictions inspired future generations of scientists, guiding them on a quest to uncover these hidden elements. Similarly, in the realm of astronomy, speculation about planets beyond our solar system ultimately led to the discovery of exoplanets. In the 19th century, astronomers such as Urbain Jean-Joseph Leverrier and John Couch Adams theorized the existence of Neptune based on the irregular orbit of Uranus. Their mathematical descriptions of this unseen world spurred further investigation, and when telescopes finally revealed Neptune, it was a triumph of theoretical science. This discovery highlighted the immense power of speculation grounded in observation, showing how it can illuminate previously unseen aspects of the universe. The development of electromagnetic theory provides yet another example of speculative thought transforming into tangible discovery. James Clerk Maxwell postulated the existence of electromagnetic waves, an idea that initially met with skepticism. His groundbreaking equations suggested that light was part of a broader spectrum of waves. Later experiments by Heinrich Hertz confirmed the existence of these waves, providing the foundation for technologies like radio and television. This evolution from imagination to reality underscores the transformative power of speculative science, as it eventually reshapes our daily lives. One of the most intriguing examples of scientific speculation comes from the early study of genetics. Gregor Mendel, through his experiments with pea plants, challenged prevailing ideas about inheritance. In the mid-19th century, Mendel proposed his laws of inheritance, but his work went largely unrecognized until the early 20th century, when scientists rediscovered his findings. This rediscovery paved the way for the modern understanding of genetics, showing how initial speculation can lay the groundwork for scientific principles that shape our understanding of life itself. The discovery of an unknown galaxy would mark a monumental shift in our understanding of cosmic evolution, revealing new insights into the processes that govern the formation and growth of galaxies. Each galaxy is a unique snapshot of the universe's history, embodying the intricate interplay of cosmic forces over billions of years. When we encounter a previously unknown galaxy, it serves as a cosmic time capsule, offering clues about the conditions that prevailed at the moment of its formation. For instance, the discovery of such a galaxy could provide crucial data on the materials available in the early universe, as well as the gravitational influences of dark matter. These factors play a pivotal role in shaping the size, structure, and evolution of galaxies. As scientists study these findings, they may be forced to reassess existing models of galaxy formation, possibly leading to the development of new theories that explain how galaxies interact with one another and evolve over time. Moreover, investigating the composition and dynamics of this new galaxy could enhance our understanding of stellar evolution. By analyzing its star clusters, astronomers could gain insights into how stars form, age, and interact in environments that differ from those in more well-known galaxies. This knowledge would help refine our understanding of the role that various elements and compounds play in regulating star formation throughout the universe. Such discoveries would not only expand our knowledge of galactic and stellar life cycles, but also provide a deeper appreciation of the complexity and beauty of the cosmos. Ultimately, each new discovery, whether it involves fundamental particles or distant galaxies, serves to deepen our connection to the universe. Every piece of knowledge gained is a step closer to understanding the grand tapestry of existence, and it all begins with the willingness to ask questions. Questions that may one day lead us to uncover even greater mysteries than we can imagine today. As we venture further into the mysteries of the cosmos, one of the most intriguing possibilities arises when we encounter galaxies that defy the conventional frameworks we have built for understanding the universe. These anomalies challenge our most fundamental assumptions about cosmic uniformity and could push us to reconsider the very foundations of astrophysics. A galaxy that deviates from known classifications isn't just an anomaly. It might serve as a gateway to new avenues of scientific thought, revealing pathways of cosmic evolution we hadn't yet considered. The more we uncover, the clearer it becomes that the universe is not the orderly, predictable place we once thought it to be. Instead, it is a vast and intricate expanse, far more varied and complex than we have ever imagined. This interplay between new discoveries and established knowledge fuels an ongoing dialogue within the scientific community, one that pushes the boundaries of human understanding and drives the relentless pursuit of knowledge. Each new revelation beckons us closer to decoding the universe's deepest secrets, urging us to keep questioning and exploring. This process of discovery, however, extends beyond mere scientific curiosity. It calls us to reflect on our own existence and place in the grand scheme of things. For centuries, humanity has defined its understanding of the universe by imposing limits on what we believe is possible, often tethering our imaginations to a reality that is finite and easily comprehensible. But what if these limits are illusory? What if, instead of being an isolated speck in a static universe, we are part of something far more expansive, an infinite cosmos with boundless dimensions and endless potential? If we shift our perspective to embrace the notion of an infinite universe, we find ourselves embarking on a profound philosophical journey, one that forces us to question not only the nature of the cosmos, but also the very meaning of our existence within it. This shift invites us to reconsider our role. Are we mere fragments in an endless expanse, insignificant in the face of the universe's vastness? Or do we possess a unique significance that connects us to the greater whole of existence? By rejecting the traditional anthropocentric view that places humanity at the center of the cosmos, we open ourselves up to the possibility that we are just one of countless forms of life, thought, and consciousness scattered across dimensions beyond our comprehension. This realization can provoke deep existential reflection, urging us to reassess our values, priorities, and responsibilities, not just to ourselves and our planet, but perhaps to other sentient beings that may exist far beyond our reach. Moreover, an infinite universe challenges the very way we think about reality itself. Philosophers and scientists alike may find themselves grappling with the fluid nature of time, space, and existence, questioning whether these concepts are fixed or whether they can transcend the boundaries we have imposed on them. Is reality something shared by all, or is it uniquely experienced by each observer? This kind of inquiry straddles the line between philosophy, physics, and metaphysics, creating an intellectual space where revolutionary ideas about consciousness and the nature of the universe can emerge. By acknowledging that we may never fully comprehend the scope of existence, we are forced to confront the limitations of our knowledge. But rather than stifling our curiosity, this acknowledgement can fuel an even greater thirst for understanding, encouraging an openness to ideas that challenge our preconceived notions and spark new lines of inquiry. In this new age of exploration, we may come to see the very pursuit of knowledge itself as an essential part of the human experience, not just the answers we find, but the questions we ask along the way. The mysteries of existence are as much a part of our journey as the discoveries we make. It is this tension between the known and the unknown that defines our intellectual and philosophical landscape, and it drives the creativity that propels us forward into uncharted territories. One of the most exciting prospects in this unfolding narrative is the potential discovery of new energy fields, energy sources that could revolutionize our approach to technology and sustainability. Imagine unlocking a form of energy that is both abundant and easily accessible, one that could rival or even replace our current reliance on fossil fuels and nuclear power. These energy fields, potentially derived from fundamental forces of nature that are still beyond our understanding, could provide us with a clean, sustainable energy source, one that could change the trajectory of human civilization. Such a discovery would not only reshape our technological landscape, but would also offer a glimmer of hope for a future where humanity is no longer dependent on polluting sources of energy. In embracing these new possibilities, we may finally be able to step into an era of environmental responsibility, where our energy consumption no longer comes at the cost of the planet's health. In the end, the exploration of the infinite universe is not just a scientific endeavor. It is a profound invitation to expand our minds, challenge our assumptions, and embrace a future where anything is possible. By reaching beyond the boundaries of what we know, we invite the unknown to guide us, to inspire us, and perhaps to teach us things we have yet to dream. The exploration of unusual energy fields could revolutionize our understanding of the universe, offering insights into phenomena we have yet to fully comprehend. As scientists continue their quest to uncover these mysterious forces, they may stumble upon technologies that manipulate energy in ways we currently consider to be pure science fiction. For example, we might envision propulsion systems so advanced that they could drastically enhance our ability to explore our solar system and far beyond. By harnessing these enigmatic energy phenomena, the possibilities for more efficient space travel could become a reality. Imagine spacecraft that travel faster and farther, opening up new frontiers for human colonization and exploration. On a smaller, more immediate scale, the integration of these energy fields into everyday technology could have profound effects on the devices we rely on. What if batteries could last for weeks without needing to be recharged, or gadgets that draw power directly from their environment, no longer tethered to traditional power outlets? These advancements could lead to an interconnected society that relies less on non-renewable resources, offering a path toward greater energy efficiency and a reduced carbon footprint. In essence, such breakthroughs could transform how we live, providing us with cleaner, more sustainable technologies that change the way we interact with the world around us. Yet, the true potential of these discoveries may not only be technological. The unraveling of strange energy fields could challenge and reshape our current scientific theories and models. Researchers may dive deeper into the realms of quantum physics and electromagnetism, potentially unlocking a new layer of understanding about the fundamental forces that govern the universe. As we peel back these layers, we may find ourselves standing on the threshold of an entirely new era of scientific and technological advancement, one that redefines our place in the cosmos. Throughout the history of science, many of the most groundbreaking discoveries have not been the result of meticulous planning or testing, but rather moments of pure serendipity. In the vast expanse of the universe, scientists often encounter anomalies that stretch the limits of their knowledge. It is in these unexpected encounters that profound discoveries are made. Take, for example, the discovery of cosmic microwave background radiation. This was not the result of an intentional experiment, but rather a random byproduct detected by radio astronomers Arno Penzias and Robert Wilson as they tried to eliminate noise from their equipment. Their chance discovery provided critical evidence for the Big Bang Theory, demonstrating how the universe's most elusive secrets can be unveiled by accident. Such moments of serendipity invite scientists to embrace curiosity, to question what they know, and to venture into the unknown. In many cases, it is the seemingly insignificant observations that lead to the most revolutionary breakthroughs. The study of distant galaxies, for instance, often presents more questions than answers. Astronomers may not know what they will find when they focus their telescopes on a remote corner of the universe, but it is in these moments that unexpected phenomena, such as fast radio bursts or the strange behavior of distant quasars, emerge, prompting reevaluations of current theories. These discoveries are the result of chance encounters, underscoring the importance of remaining open to the unknown. In science, even the most meticulously planned experiments can lead to surprising outcomes, reminding us that the universe has a way of continually surprising us. The confirmation of anomalies that hint at the existence of unknown entities would have a profound impact not only on our scientific understanding, but also on society as a whole. Such a revelation would force humanity to reassess its place in the cosmos, sparking a range of reactions, from fear and skepticism to excitement and curiosity. How society responds to such a discovery will shape our future. Governments, scientists, and educators must engage in transparent communication, sharing information with the public as quickly and accurately as possible to prevent the spread of misinformation. The media, public forums, and scientific discussions would all play vital roles in shaping how these revelations are perceived. The role of education in this process would be critical. Society must understand the scientific context surrounding these discoveries, helping guide public perception and emotional responses. In parallel, interdisciplinary collaboration would become essential. Ethicists, sociologists, psychologists, and scientists would need to engage in deep conversations about the potential implications of such discoveries on human culture, beliefs, and systems. What might the existence of these entities mean for our understanding of life, consciousness, and the very definition of existence? These questions would spark a broader discourse that grounds societal responses in mutual understanding rather than fear or division. Instead of retreating into apprehension, society could use these discoveries as a platform for curiosity and exploration. This could open the door to new initiatives that encourage research, dialogue, and interplanetary cooperation. Humanity, confronted with the mysteries of the universe, might choose to embrace unity and purpose, focusing on the shared experience of being part of a broader cosmos. A collective effort to understand these anomalies could mark a transformative chapter in human history, one in which collaboration and exploration take precedence over division. The concept of a multiverse, where countless universes coexist, each with its own set of physical laws and conditions, could radically alter our understanding of free will and fate. In a deterministic universe, every action and consequence can be traced back to prior events, suggesting a kind of preordained fate. However, if our universe is but one of many, the implications for human agency, choice, and existence could be profound. The discovery of a multiverse would not only challenge our existing models of physics, but could also fundamentally alter the way we view ourselves and our place in the grand scheme of reality. However, if we entertain the notion of a multiverse, where every possible outcome of every decision manifests in parallel realities, the implications of our existence and understanding of the universe shift dramatically. Imagine a scenario where every single choice we make, no matter how insignificant it may seem, spawns a new universe, a new branch of reality. In this framework, every possibility becomes a tangible reality, and our lives unfold through just one of the countless potential trajectories that could have emerged from each decision. This perspective radically redefines our concept of existence, where the complexity and vastness of choices give birth to innumerable outcomes, some of which may diverge significantly from the life we experience. In such a reality, free will takes on a new dimension. Rather than being a force confined to making singular, high-stakes decisions within a universe already determined by certain laws or parameters, it becomes more about navigating through a vast, endless landscape of potential. Every choice we make might no longer be a path to a fixed future, but rather a branching point, one that generates infinite possibilities, each unfolding in a separate realm. The sheer number of alternate realities existing simultaneously could render the idea of fate or destiny as we know it somewhat obsolete. Each moment of decision, no matter how small, could result in an alternate timeline, with its own unique set of circumstances, challenges, and outcomes. Moreover, the existence of a multiverse might provide a new lens through which we can view events in our own lives that seem tragic or unjust. In this broader context, one universe might witness the success of a particular decision, while another might bear witness to failure. A tragedy in one world could be nothing more than a fleeting inconvenience in another, and vice versa. The idea that there are infinite versions of ourselves living out different decisions and their consequences in different realms highlights the inherent randomness and complexity of existence. It suggests that every decision, while undeniably significant within our reality, is only one small piece of a much larger, ever-expanding puzzle. The consequences of our actions, therefore, may not be as weighty as we believe, as in another universe, a different choice could have led to an entirely different outcome. This philosophical shift could compel us to rethink how we perceive our actions, our agency, and even our responsibilities. Free will might no longer be seen merely as the privilege of making choices within a single predetermined universe, but as a profound engagement with a reality rich with potential. Rather than feeling weighed down by the weight of our decisions, we may come to view each choice as part of a much grander narrative, one that stretches across an infinite array of universes, each full of its own mysteries and opportunities. This shift in perspective may lead us to a deeper sense of curiosity about the very nature of existence, encouraging us to explore the limitless possibilities that arise from our every action. As we ponder the implications of a multiverse, questions about purpose and significance naturally arise. If all possible outcomes are realized somewhere, what does that mean for our drive to make meaningful change within our own universe? If in one reality our efforts to effect change bear fruit, but in another they are futile, does that diminish the importance of striving for progress? Understanding this paradox might alter our perception of free will, imbuing it with a new sense of complexity and mystery. It could lead us to reimagine the very nature of our existence, prompting us to explore the deeper fabric of reality and recognize that the true value of our lives may not lie in the singular outcomes we achieve, but in the journey itself, filled with endless possibilities. On a different front, the notion of exotic matter holds incredible promise, especially when it comes to advancing our capabilities in space travel and exploration. Unlike ordinary matter, which behaves according to well-understood principles, exotic matter is characterized by peculiar properties such as negative mass or negative energy. These unconventional traits could unlock technological innovations that stretch the very boundaries of our current understanding of physics, particularly when it comes to the possibility of faster-than-light travel. Imagine the possibilities if we could harness negative energy density to create a warp bubble. This hypothetical bubble would allow a spacecraft to travel across vast interstellar distances at speeds faster than the speed of light without violating the fundamental laws of physics. Instead of moving through space in the traditional sense, the spacecraft would compress the fabric of space in front of it and expand it behind it, creating a warp in the space-time continuum. This mechanism would enable rapid travel across the cosmos, potentially allowing us to reach distant stars and galaxies in a matter of days or weeks rather than centuries. The idea is rooted in general relativity, which, although suggesting that faster-than-light travel is impossible, leaves the door open for innovative ideas that could bypass the universal speed limit. Furthermore, the unusual properties of exotic matter could revolutionize the way we generate and store our energy in space. Traditional propulsion systems, which rely on chemical or nuclear reactions, have limitations in terms of efficiency and the sheer amount of fuel required for long-duration missions. With exotic matter, we could potentially develop entirely new sources of energy that might harness the very fabric of space itself, tapping into the vacuum energy that permeates the cosmos. This could provide near-limitless energy for spacecraft, enabling long-term missions that could span decades or even centuries. Such advancements would not only reduce our reliance on terrestrial resources, but could also pave the way for sustainable human presence on other celestial bodies, such as Mars or even farther afield. The ability to access and manipulate exotic energy sources would mean that future missions to distant planets could be carried out with greater efficiency and lower costs, making space exploration a feasible, ongoing endeavor. Moreover, mapping regions beyond the observable universe could fundamentally change our scientific approach to understanding the cosmos. Currently, our observations are limited to about 13. 8 billion years of light travel time, which constrains our knowledge to a spherical region around us. If we could extend our mapping beyond this observable horizon, researchers would gain access to regions of space that are currently beyond our reach, regions that may contain entirely new cosmic structures, phenomena, and patterns. This data could open new avenues for groundbreaking discoveries in fields like astrophysics and cosmology, offering fresh insights into the nature of the universe and its expansion. One major impact would be on our cosmological models. With access to information about regions that have not yet been observed, scientists could refine, adjust, or even radically redefine existing theories about the universe's structure, expansion, and the distribution of galaxies. New discoveries could challenge our current understanding of phenomena like dark matter and dark energy, two of the most elusive and enigmatic components of the universe. These findings could provide the missing pieces to the puzzle, helping scientists finally unlock the mysteries of these unseen forces that influence the fabric of reality itself. The shift from a limited view of the cosmos to one that stretches far beyond the horizon would not only expand our knowledge, but also inspire a new generation of explorers and thinkers eager to unravel the infinite complexities of the universe. If these unseen regions of the universe were to reveal entirely new physical laws or uncover previously unknown behaviors of matter and energy, it could set the stage for revolutionary technological advancements. The development of instruments capable of detecting phenomena that these new regions propose could spark innovations that echo past breakthroughs, such as the discoveries made through radio astronomy, which opened up vast, previously hidden realms of cosmic activity. To finally understand what lies beyond the limits of our observable universe would not just enrich our scientific comprehension, but also fuel profound philosophical inquiries into the very essence of our existence. Scientists, philosophers, and thinkers from all walks of life would find themselves grappling with some of the most fundamental questions that have long plagued humanity. What is infinity? What is the true nature of reality? Is the universe inherently uniform, or does it contain diverse structures and patterns, each with its own mysteries to unravel? Such a monumental shift in our scientific understanding would undoubtedly inspire generations of researchers and enthusiasts to dive deeper into the very fabric of existence. The discovery of new knowledge, especially knowledge that forces us to reconsider humanity's role in the cosmos, could lead to a profound reassessment of our place within the universe. Some findings might suggest that, far from being central to the cosmic narrative, humanity may be just a fleeting moment in an almost incomprehensibly vast and intricate universe. Revelations of this nature could challenge deeply ingrained beliefs, leading to significant shifts in societal structures and worldviews. Preparing for such a societal transformation requires a multi-pronged approach. Education must be at the heart of this preparation. By providing future generations with a robust understanding of science and cosmology from an early age, we can equip them with the intellectual tools to critically engage with new discoveries. Curricula should not only emphasize the scientific data, but also foster philosophical discussions about humanity's place in the universe. As students learn about the vastness of space, the potential for extraterrestrial life, and the complexities of cosmic phenomena, they will develop a more nuanced perspective, one that balances awe with humility. Equally important are cultural dialogues, creating spaces where diverse viewpoints on the implications of these discoveries can be openly shared and discussed. Engaging in thoughtful conversations with philosophers, theologians, scientists, and the general public ensures that society can collectively grapple with the broader existential questions these discoveries raise. This collective exploration helps mitigate fears and fosters a sense of wonder and curiosity, rather than dread. It allows society to embrace the unknown not as something to fear, but as an opportunity for growth and understanding. Moreover, continuous engagement with the scientific community and a sustained commitment to scientific literacy are critical as these discoveries unfold. Scientists must communicate their findings clearly and responsibly, ensuring that the public is not only informed but also engaged in the process of discovery. Public outreach initiatives, led by institutions and scientific organizations, can spark curiosity and create connections between people and the cosmos. By involving society in the journey of discovery, we ensure that the implications of scientific advancements are understood not as overwhelming complexities, but as the beginning of a new chapter in our shared quest for knowledge. Anomalies in scientific observations often ignite a sense of wonder, compelling us to re-examine our understanding of the universe. These unexplained phenomena challenge established frameworks of knowledge and urge scientists to rethink their current assumptions. For instance, the discovery of strange cosmic structures, such as vast voids or unusual galaxy formations, can prompt a re-evaluation of the distribution of matter throughout the cosmos. Each new discovery becomes a piece of a vast, intricate puzzle that pushes us to refine our models of how the universe operates. Models that can, in turn, alter our understanding of humanity's place within this grand cosmic expanse. Furthermore, these anomalies might point to the presence of unknown forces or materials, such as dark matter and dark energy, mysterious components that we cannot directly observe, but that shape the universe in ways we are only beginning to understand. The very inconsistencies these anomalies reveal in our expectations may lead researchers to profound new insights into the fundamental laws of physics. The more we explore, the more it becomes clear. We are still in the early stages of understanding not only the universe, but also our own existence within it. Philosophically, each new anomaly invites deeper reflection about the uniqueness of humanity's position in the cosmos. Are we merely insignificant observers, adrift in an ever-expanding universe, or do these anomalies hint at something more profound about our consciousness, our capacity for observation, and our innate drive to understand? Each discovery offers us an opportunity to reconsider what it means to be human in a universe that is far more complex and possibly teeming with life than we have ever imagined. As we confront potential for breakthroughs, whether through the discovery of extraterrestrial life or the revelation of new physical principles, we are compelled to reconsider not just our scientific theories, but our philosophical outlook on life's place in this vast, swirling tapestry of existence. Exploring the unknown regions of the universe also brings with it a host of ethical considerations that challenge the very notion of exploration itself. At the forefront of these concerns is the question of how we should approach environments that may harbor forms of life, whether they are complex organisms or microscopic life forms. As we extend our reach into space, the possibility of discovering extraterrestrial life carries profound ethical implications, prompting us to reflect on the rights of these life forms and our responsibility toward them. Should we interfere with their ecosystems? Should we impose our human understanding on their existence? These ethical dilemmas echo historical encounters between different cultures on Earth, where the question of how to approach the other has long been a source of moral debate. Our growing awareness of the potential diversity of life forms beyond our planet forces us to confront similar questions on a cosmic scale. As we continue to explore the universe and uncover its secrets, we must be prepared to grapple with the complexities of our actions, ensuring that our pursuit of knowledge is guided by a sense of responsibility, respect, and humility. In the end, as we stand on the precipice of these discoveries, we must approach our role in the universe with both curiosity and caution. The cosmos is vast and full of mysteries, but how we choose to engage with these revelations will define not just our understanding of the universe, but our understanding of ourselves. The exploration of distant planets and moons, while a remarkable step forward in human achievement, brings with it profound ethical and practical concerns. As we venture beyond Earth's atmosphere, the risks associated with contamination become increasingly apparent. Human missions, despite their scientific and exploratory ambitions, pose the threat of altering the natural state of these celestial bodies. More concerning still is the possibility that Earth-based organisms carried by our spacecraft or astronauts might be introduced to environments that could harbor unique local life forms. These alien ecosystems could be disrupted, with Earth organisms potentially outcompeting or even wiping out indigenous life, should it exist. This dilemma underscores the vital importance of establishing rigorous planetary protection protocols to safeguard the integrity of extraterrestrial worlds. As scientists and space agencies around the globe continue to push forward in their efforts to explore, they are not only concerned with preventing contamination of distant planets, but also with the need to protect the Earth from potential biohazards. This dual concern, known as forward and backward contamination, involves ensuring that space missions don't bring harmful microorganisms back to Earth, which could pose unforeseen risks to our ecosystems or public health. In addressing these concerns, there is a growing consensus among researchers and policymakers that we must tread lightly, acting with the utmost caution and responsibility as we explore new worlds. However, the ethical considerations surrounding space exploration extend beyond the realm of planetary protection. The allocation of vast resources towards the pursuit of knowledge in space raises difficult questions about how we prioritize spending in a world facing urgent challenges. Issues such as poverty, inequality, and environmental degradation continue to affect millions of people, and many argue that the immense sums invested in space exploration could be better spent addressing these crises here on Earth. This ethical debate highlights a tension between the allure of technological progress and the immediate needs of our global society. Proponents of space exploration contend that advancing our knowledge is crucial not just for scientific discovery, but for the long-term survival of humanity itself. They argue that space exploration could yield transformative benefits, such as new technologies, resources, and insights that may ultimately help solve the problems we face on Earth. Yet, detractors question whether this vision is too distant and idealistic when set against the urgent needs of today's society. Further complicating this ethical landscape is the question of who benefits from the technologies and advancements spurred by space exploration. As we push the boundaries of what is possible through technological innovation, we must confront the reality that these advancements may not be equitably distributed. Technology has the potential to exacerbate existing inequalities, whether through unequal access or skewed applications that favor the rich and powerful. This raises important ethical questions about how we ensure that the benefits of these breakthroughs are shared more broadly, rather than being confined to a select few. When exploring new frontiers, it is crucial that we do so with a sense of responsibility toward all of humanity, ensuring that technological advancements are harnessed for the greater good, not just the enrichment of the few. The ethical implications of space exploration are not limited to resource allocation or the potential for inequality. As scientists uncover groundbreaking discoveries in space, they must also navigate a complex landscape of responsibility. Every new anomaly, whether an unexpected astronomical phenomenon, the discovery of a new material, or the observation of an unforeseen biological response, carries with it the potential for profound implications, not just for science, but for society as a whole. This is where the process of peer review and scientific collaboration plays a critical role. Before any findings are published or acted upon, they undergo rigorous scrutiny by fellow experts in the field. This system of checks and balances ensures that the interpretations of data are sound and that the potential consequences of new discoveries are carefully considered. Multidisciplinary collaboration is also essential in this process, with teams drawing from a diverse range of fields to evaluate the possible ramifications of their work. This approach encourages critical thinking and fosters a dialogue about not just what can be done, but what should be done. For scientists, exploring new phenomena involves more than just the pursuit of knowledge. It demands a thoughtful consideration of how their discoveries might affect society, both now and in the future. Engaging with the public, policymakers, and ethical boards becomes an essential part of this process, ensuring that scientific advancements are communicated responsibly and that their potential risks or ethical dilemmas are addressed head-on. As we venture further into the cosmos, scientists are increasingly aware of the need for foresight in their research. Identifying and assessing potential consequences should be an integral part of the scientific process, allowing researchers to carefully navigate the fine line between innovation and caution. The ethical dimensions of space exploration are no longer an afterthought, but are woven into the very fabric of scientific inquiry. By fostering an ongoing dialogue about these issues, scientists can explore new frontiers while remaining mindful of their responsibilities to humanity and to the planet they call home. At the heart of space exploration lies a profound responsibility. We are not merely explorers venturing into the unknown. We are custodians of not just our own planet, but of any other ecosystems or intelligences we might encounter in the vast reaches of the cosmos. The prospect of encountering alien life or pristine environments is thrilling, yet it also brings with it the weight of ethical duty. We must not allow our quest for knowledge to come at the expense of other beings or ecosystems. When we explore celestial bodies, whether planets or moons, we must ensure that we do not contaminate them with Earth-based microorganisms. As such, contamination could forever alter these environments and compromise our ability to study them in their untouched state. To address this, space agencies worldwide adhere to strict planetary protection protocols designed to preserve the integrity of extraterrestrial worlds and prevent contamination. These protocols are not just a precaution. They are a fundamental part of the ethical framework that guides human exploration beyond Earth. By carefully managing the risk of contamination, we can ensure that our explorations respect the very essence of the celestial bodies we seek to understand. In doing so, we honor not only the potential for discovery, but also our responsibility to protect the unknown and to tread lightly on the new worlds we encounter. As we turn our gaze beyond the familiar boundaries of our solar system, the prospect of sending spacecraft to distant stars and planets sparks a profound reconsideration of our place in the cosmos. This is not merely a technical challenge, but a moral and philosophical one. What would it mean for humanity to venture into the vast unknown of space? What would our presence in the broader universe signify? And how might it impact civilizations, potentially far more advanced than our own, that we have yet to encounter? At the heart of these questions lies one of the most pressing ethical dilemmas humanity may ever face: the possibility of discovering intelligent extraterrestrial life. Should we, as a species, engage with other civilizations? If so, how do we approach them with humility, respect, and a commitment to uplift rather than exploit? These questions are not hypothetical. They are central to how we, as explorers, prepare for the future of interstellar interaction. Our first responsibility must be to ensure that our actions in space are in harmony with the values we espouse here on Earth. As we contemplate the potential for communication with intelligent beings from another world, we must also be mindful of the lessons we have learned, or in some cases failed to learn, about respecting the autonomy of other cultures and ecosystems. Engaging with extraterrestrial life should not be seen as an opportunity for colonization or coercion. Instead, our primary aim must be to create connections built on mutual respect and understanding. The implications of our first steps into interstellar space would ripple across many dimensions of human thought and action. If we make contact with microbial life, the ethical concerns might center around the protection of Earth and the preservation of biosafety protocols. But should we encounter civilizations with advanced intelligence, we would find ourselves confronting questions of much greater magnitude. Questions about rights, agency, and governance. Would these beings be entitled to the same ethical considerations we afford our fellow humans? Could we even contemplate creating a form of interstellar diplomacy, governed by principles we have yet to fully define? One of the most important ethical challenges in this context would revolve around the principle of non-interference. As humans, we have a history of intervening in ecosystems, societies, and environments that we don't fully understand. But what if we were to encounter a civilization whose social structures, environments, and cultures were radically different from our own? Would we have the right or the responsibility to offer assistance or impose our values upon them? How might our actions reshape their society, for better or worse? Beyond these immediate concerns, the discovery of extraterrestrial life could lead to a radical rethinking of our role in the universe. For centuries, humans have held to an anthropocentric view of the cosmos, believing ourselves to be the most advanced and significant life forms. The discovery of extraterrestrial life, however, could shatter this illusion. It would force us to reconsider our moral frameworks and ethics in much the same way we have reevaluated our treatment of animals, ecosystems, and other forms of life on Earth. Could this challenge lead us to a more inclusive, interconnected understanding of life that transcends the boundaries of Earth itself? In many ways, The dialogue between species, whether earthly or extraterrestrial, would not only expand our scientific horizons, but deepen our ethical reflections. If we approach such a discovery with the right mindset, we might find that the lessons we learn from other civilizations, if they exist, could help us address the most pressing issues we face on our home planet. Climate change, biodiversity loss, and social inequality all demand our attention, and the pursuit of space exploration should reinforce, not distract from, our commitment to addressing these crises here on Earth. Ultimately, the challenges we face on Earth should guide our approach to space exploration, ensuring that we are acting as responsible stewards of both our planet and the larger cosmos. As we peer deeper into the mysteries of the universe, we are confronted with an undeniable truth. Our exploration of the unknown must be tempered with a deep sense of responsibility. The vastness of the cosmos holds mysteries beyond our comprehension, and every new discovery brings with it new questions about our ethical obligations. It is not enough to simply seek knowledge. We must also consider the consequences of our actions. In this way, our exploration of space should be guided by a commitment to transparency, collaboration, and shared responsibility. Transparency is perhaps the most important principle to uphold in the pursuit of knowledge. As humanity ventures into the unknown, we must ensure that discoveries and the methodologies we use to investigate them are made available to the global scientific community and the broader public. This openness fosters an environment of collective knowledge, where ethical concerns can be openly discussed and addressed. Equally important is collaboration. As we embark on the quest to explore anomalies at the far reaches of the universe, it is crucial that we engage a wide range of experts, scientists, ethicists, philosophers, and others in this journey. The ethical implications of our discoveries will not be easily resolved, and no single discipline or worldview can provide all the answers. By bringing together a diversity of perspectives, we can create a more holistic understanding of the potential risks and rewards of space exploration. Finally, ethical primacy must remain at the center of our discussions about the future of space exploration. Just as we have learned on Earth, our actions in the cosmos must be guided by a principle of non-harm. Whether we are exploring distant planets or encountering extraterrestrial life, we must strive to avoid actions that could cause harm to other forms of life or disrupt cosmic phenomena. In this way, we can ensure that the pursuit of knowledge does not eclipse our ethical responsibilities. This requires establishing international guidelines and agreements to ensure that humanity's actions in space are aligned with the highest ethical standards. The universe may be vast and full of untold mysteries, but as we reach out into the unknown, we must do so with a profound sense of responsibility. By acting with humility, respect, and a commitment to ethical conduct, we can ensure that the exploration of space is not only a journey of scientific discovery, but also a journey toward a deeper understanding of our place in the cosmos. The universe, with all its vast complexities, continually reminds us of the limitations of our current understanding. At the heart of this realization lies the need for humility, a quality that is essential as we embark on the grand adventure of cosmic exploration. We are standing at the threshold of unknown realms, where every new discovery could both redefine the boundaries of science and deepen our sense of wonder. Yet, this journey requires patience and an openness to learning. Rather than rushing into intervention, the key lies in taking cautious, deliberate steps forward, with a profound respect for the mysteries that remain concealed in the cosmic vastness. Humanity's approach to the enigmatic frontiers of space should, therefore, be rooted in a spirit of wonder and curiosity. But above all, it must be underscored by an unwavering respect for the universe in its current state and for the uncertainties it holds. The desire to uncover the secrets of the cosmos should not overshadow the reverence we owe to the uncharted realms. By embracing these principles, we open ourselves to the possibility of an extraordinary chapter in our cosmic journey, one that honors both our unrelenting thirst for knowledge and the awe-inspiring mysteries that still lie beyond our reach. The philosophical questions surrounding the ethics of exploration play a crucial role in shaping the trajectory of scientific discovery, particularly when it comes to studying the most elusive phenomena of the universe. As scientists peer deeper into the unknown, examining black holes, dark matter, and the potential for extraterrestrial life, they are confronted with profound ethical dilemmas. These questions force us to consider not just what can be explored, but also what should be explored. Such considerations are not merely academic, they are deeply intertwined with our values as a species and our responsibility to protect the integrity of life in all its forms. One of the most compelling ethical quandaries is the potential discovery of extraterrestrial life. If life forms exist beyond Earth, should we, as humans, attempt to make contact with them? The ethical implications are vast. We must grapple with the potential risks of human interference in an entirely alien ecosystem, weighing the moral obligation to protect that system against the allure of discovery. Ethical principles guide us toward an approach that balances curiosity with caution, urging scientists to consider the long-term effects of their work. It's a delicate dance, an unyielding pursuit of knowledge that does not come at the cost of responsibility. As we venture further into space, the questions we must answer go beyond the scientific. How do we ensure that our missions do not cause harm to our planet or to others we may discover? This concept extends to our use of advanced technology. The development of powerful telescopes, spacecraft, and other instruments requires vast resources, often with significant environmental costs. In these discussions, philosophy and ethics play a crucial role, pushing us to reflect on issues such as sustainability, equity, and justice. By weighing the impact of our technological choices, we can ensure that we are not driven by personal or institutional gain, but by a genuine commitment to the well-being of humanity and the preservation of our shared universe. Ultimately, the intersection of ethics and science creates a culture of responsibility. It invites reflection on the broader implications of our actions. As we delve deeper into the universe's many anomalies, we must remain aware of the profound impact our explorations could have, not just on our world, but on the cosmos at large. This ongoing dialogue between science and philosophy ensures that our pursuit of knowledge is not only about understanding the universe, but also about respecting the fundamental principles that govern life itself. The contemplation of life forms residing in cosmic anomalies, particularly at the very edges of the universe, compels us to expand our definitions of what constitutes life. The boundaries of what is possible stretch far beyond our current understanding, especially when we encounter phenomena that defy traditional laws of physics. Black holes, for example, warp space and time, pulling light into their grasp and creating event horizons that are both thresholds and barriers. These celestial oddities challenge our assumptions about how life could exist in such extreme environments. Could there be organisms that have evolved to thrive in these places, utilizing forms of energy and survival strategies beyond anything we could imagine? The question deepens further when we explore the theory of parallel universes. If there are multiple universes, each governed by different physical laws, could there be sentient beings living in realms that are beyond our comprehension? These hypothetical realms might feature entirely different structures of matter and energy, and their inhabitants might possess intelligence that defies our understanding. Could life evolve in ways that we simply cannot fathom, in environments shaped by the strange and complex anomalies scattered across the cosmos? As we explore these possibilities, we find ourselves at the intersection of science and philosophy. The quest to understand whether these cosmic anomalies could serve as homes for sentient life urges us to rethink our assumptions about intelligence, consciousness, and what it truly means to be alive in a vast and mysterious universe. Every new discovery in astrophysics and cosmology challenges our understanding, expanding the horizons of what we can imagine, and inspiring us to continue pushing the boundaries of our knowledge. With each new finding, we are reminded of how much we still have to learn, both about the universe and our place within it. Public engagement plays a critical role in shaping the ethical framework that governs our exploration of space. As humanity's reach extends beyond Earth, it becomes increasingly important to involve the public in conversations about the consequences of space exploration. These discussions provide a necessary bridge between the scientific community and society at large, helping to ensure that a diversity of ethical perspectives are taken into account. Issues such as planetary protection, the use of resources, and the potential discovery of extraterrestrial life are complex and multifaceted, and they require input from all corners of society. By including the public in these discussions, we foster a sense of collective responsibility over the course of space exploration. As citizens become more informed about the risks and rewards of our ventures into space, they can actively contribute to determining the priorities that should guide these efforts. In this way, the ethics of cosmic exploration are not left solely to scientists and policymakers, but are woven into the fabric of society itself. Through broad, inclusive conversations, we can ensure that the ethical concerns surrounding space exploration are not merely the domain of a select few, but are shared and addressed as a collective responsibility. The future of humanity in space is a future we must build together, with respect, responsibility, and a deep commitment to the wonders of life in all its forms. In the realm of cosmic exploration, public engagement plays a crucial role in fostering trust and transparency between scientific communities and the wider public. When the objectives, processes, and potential consequences of space missions are clearly communicated, it creates an environment conducive to open, informed discussions. These conversations allow citizens to voice their hopes, concerns, and questions about the future of space exploration, facilitating a deeper connection between society and scientific endeavors. This kind of transparency does more than just inform. It also lays the groundwork for broader public support. When the public feels that their concerns are acknowledged, their trust in space missions and research strengthens, and it often leads to more substantial backing for these endeavors. Furthermore, such transparency plays a pivotal role in guiding responsible decision-making, ensuring that the actions of scientists and space agencies align with societal values and priorities. The ethical questions tied to exploring the cosmos are monumental, addressing not only the sustainability of our efforts, but also the broader responsibilities humanity faces as it steps into the unknown. Themes of stewardship, sustainability, and the long-term well-being of humanity must be considered as we embark on this journey. Engaging the public in conversations about these issues allows scientists, ethicists, and other stakeholders to navigate the complexities of space exploration with a sense of shared responsibility. By making sure that ethical considerations guide the pursuit of knowledge, we ensure that our collective journey is not solely driven by the quest for discovery, but is also grounded in moral accountability. For scientific advancements to truly benefit society, there must be a concerted effort to communicate findings in an inclusive and accessible way. Scientific discoveries, no matter how groundbreaking, lose their potential if they are not effectively shared with the public. Researchers must take care to present their work in formats that reach a wide audience. Clear explanations, whether through articles, documentaries, or public talks, are vital in breaking down complex concepts and making them approachable. In doing so, we foster a culture of curiosity, inquiry, and understanding, where society is not merely passive, but actively engaged with scientific progress. This approach helps demystify advanced scientific ideas, ensuring that even those without a scientific background can appreciate and participate in these advancements. Education is also a cornerstone of this effort. Integrating cosmology and scientific discoveries into school curricula sparks early interest and provides students with the tools to understand the universe from an informed perspective. By preparing the next generation of scientists, we not only equip them to push the boundaries of knowledge, but also cultivate a society of informed citizens who can engage meaningfully with scientific and technological progress. Initiatives aimed at improving science literacy, such as community discussions, workshops, and public lectures, play an essential role in bridging the gap between the scientific community and the general public. These efforts foster mutual understanding and collaboration, allowing for a more informed dialogue on scientific advancements. Collaborative efforts between scientists, policymakers, and community leaders amplify the positive impacts of scientific progress. By incorporating diverse perspectives into the decision-making process, we can craft strategies that are more comprehensive and inclusive. This collective approach ensures that scientific advancements, whether in healthcare, environmental protection, or technology, are applied in ways that directly benefit society. When diverse viewpoints are brought to the table, solutions are more likely to address the unique needs and values of different communities, ensuring that science works for everyone. Ethical considerations must remain at the forefront of all scientific endeavors, especially as we explore further into the cosmos. Each new discovery, each new technology brings with it a set of responsibilities. As we uncover the mysteries of the universe, we must be vigilant in considering the potential consequences of our actions. How might our new findings impact the environment? What will be the societal implications of these discoveries? How can we ensure that the benefits of scientific advancements are equitably distributed? These are questions that demand careful thought and consideration. Reflecting on these issues is essential for creating a future where scientific progress enriches the lives of all people, not just a select few. The exploration of the cosmos inevitably raises profound ethical dilemmas that mirror the challenges we face here on Earth as we venture into uncharted territories. Exploring distant planets, moons, and asteroids, we must confront questions that parallel the dilemmas we face in our own world. The challenge of resource allocation, for instance, is one of the most pressing ethical issues tied to space exploration. How do we balance the immense costs of space missions with the urgent needs of our planet, such as addressing poverty, healthcare, and education? Should we divert precious resources from these critical issues to fund the exploration of space? This debate goes beyond simply determining the value of scientific discovery. It speaks to the broader question of how we prioritize the well-being of our planet and its inhabitants. Our exploration of space also raises important questions about environmental responsibility. As we look toward colonizing other planets or harvesting resources from asteroids, we must ask ourselves, what moral obligations do we have to the pristine environments we may encounter? If we struggle to maintain the ecological balance on our own planet, how can we justify intervening in untouched ecosystems beyond Earth? The ethical challenges of space exploration are not confined to the scientific realm. They extend to the very heart of what it means to be responsible stewards of the Earth and beyond. These are questions that cannot be answered lightly, and they demand a thoughtful, careful approach to ensure that humanity's reach into the cosmos does not come at the expense of our moral obligations to the world we call home. As we continue to push the boundaries of knowledge and explore the vast reaches of space, it is imperative that we do so with both curiosity and caution. The decisions we make today will shape not only the future of space exploration, but also the future of humanity itself. With transparency, ethical reflection, and inclusive dialogue, we can ensure that our journey into the cosmos serves not just the advancement of science, but the collective good of all people. As humanity ventures deeper into the vast expanse of space, we are confronted with a new set of ethical considerations that challenge both our technological capabilities and our moral compass. These questions mirror those we encounter in our daily lives, yet they carry a weight of cosmic significance. As we develop more autonomous spacecraft and intelligent systems, the potential for machines to make decisions without human input becomes a pressing concern. This dilemma is not confined to the realm of space exploration alone. It reflects broader societal debates about our growing reliance on technology and the moral responsibilities that come with creating machines capable of independent action. The ethical implications of artificial intelligence in space exploration prompt us to question the kind of world we wish to build, not only on Earth, but also in the farthest reaches of the cosmos. As AI systems become more autonomous, we must consider what it means for machines to make life-altering decisions in a vacuum without human oversight. The convergence of our pursuit of knowledge about the universe and these ethical concerns encourages us to reflect on the values that should guide our exploration of the final frontier. How do we balance the pursuit of scientific discovery with the responsibility of safeguarding humanity's interests, both now and in the future? Looking ahead, the horizon of space exploration is lit up by a host of emerging technologies that promise to push the boundaries of what is possible. The future of space travel is being shaped by innovations that will not only expand our capabilities, but also bring us closer to the outer edges of the universe. One of the most exciting developments is the advancement of propulsion systems. Conventional chemical rockets have served us well for decades, but they have limitations when it comes to reaching distant destinations. New propulsion technologies, such as ion propulsion and nuclear thermal propulsion, could significantly reduce travel time and bring planets like Mars within reach in a matter of months rather than years. Ion propulsion systems, for example, work by expelling charged particles at extremely high speeds, creating a continuous thrust that, although gentle, can accumulate over time to propel spacecraft to extraordinary velocities. This method of propulsion could revolutionize the way we travel to distant planets and moons, dramatically cutting down the time it takes to explore the farthest reaches of our solar system and beyond. Similarly, nuclear thermal propulsion has the potential to provide even more power, allowing for faster travel to destinations like the outer planets and their moons. Another groundbreaking area in space exploration is the integration of artificial intelligence, AI, and machine learning, ML, into space missions. These technologies are capable of processing vast amounts of data at speeds far exceeding human abilities, enabling real-time decision-making that can enhance the effectiveness of space missions. Imagine a rover on Mars, guided by AI, autonomously selecting the most scientifically valuable rocks to analyze or navigating complex terrain without the need for direct human intervention. Such advancements would not only improve the efficiency of space missions, but also open up new possibilities for exploration, especially in environments where human oversight is impractical or impossible. Moreover, the integration of AI into spacecraft and mission planning could allow for more profound, deeper space exploration. With machines handling routine tasks and data analysis, human explorers can focus on more complex, long-term scientific goals. This shift could redefine the nature of space exploration by giving humanity the freedom to explore without being constrained by the limitations of time or constant supervision. In addition to AI and propulsion innovations, advances in material science are set to revolutionize spacecraft design. Lighter, stronger materials could make spacecraft more durable and efficient, reducing the amount of fuel required to reach orbit and increasing the safety of long-duration missions. One such material is graphene, a single layer of carbon atoms arranged in a two-dimensional honeycomb structure. This material has the potential to create spacecraft that are not only lighter but also more resilient, able to withstand the harsh conditions of space travel while maintaining the structural integrity needed for extended missions. Another exciting prospect is the development of space habitats built from resources found in space itself. Technologies like 3D printing could enable us to construct structures using materials found on the Moon, Mars, or asteroids. By utilizing in-situ resources, we could create sustainable habitats for long-term missions, reducing the need to transport materials from Earth. This could be a game changer for future space exploration, enabling humanity to establish a permanent presence on other planets and moons while continuing to push the boundaries of scientific research. With these new technologies on the horizon, the prospect of expanding humanity's presence in space seems increasingly achievable. The combination of AI, advanced propulsion systems, revolutionary materials, and sustainable habitats could transform space exploration, making it more efficient, effective, and far-reaching. But as we take these giant leaps into the unknown, we must do so with a sense of ethical responsibility, ensuring that our actions today pave the way for a sustainable and equitable future in space. In this pursuit, international collaboration plays a pivotal role. Space exploration is not a single nation's endeavor, but a global effort, one that requires pooling resources, expertise, and data to make significant progress. By working together, countries can conduct research that no single nation could achieve alone. Different countries bring unique technologies, perspectives, and methodologies to the table, fostering innovation and expanding the reach of scientific discovery. The collective efforts of scientists from around the world enhance our understanding of cosmic anomalies and provide us with the tools to observe and analyze phenomena that challenge the very boundaries of our knowledge. A prime example of such collaboration is the Event Horizon Telescope project, which involves multiple space agencies and institutions from across the globe. This international team of scientists and engineers succeeded in capturing the first ever images of a black hole, a monumental achievement in the field of astrophysics. By sharing observations and synchronizing data from various locations on Earth, researchers were able to increase the resolution and clarity of their findings. This collaborative effort not only paved the way for future discoveries, but also accelerated the dissemination of knowledge throughout the scientific community, making it possible for researchers across the world to build on the groundbreaking work of their peers. As humanity continues to explore the mysteries of the universe, we are reminded that the pursuit of knowledge is not solely about technological advancements. It is also about working together across borders and cultures to unravel the secrets of the cosmos. The intersection of innovation, ethics, and international cooperation will shape the future of space exploration, guiding us toward a deeper understanding of our place in the universe and the potential for humanity's future beyond Earth. International collaboration in scientific research is one of the most powerful catalysts for innovation, fostering creativity and new perspectives that are essential for tackling some of the universe's most perplexing and complex questions. When scientists from different corners of the world come together, they bring with them a rich variety of cultural viewpoints and scientific backgrounds. This diversity is invaluable, as it enables the formulation of novel hypotheses, groundbreaking experiments, and fresh approaches to problems that have long eluded even the most brilliant minds. Take, for example, the study of dark matter and gravitational waves. These enigmatic phenomena present challenges that, while deeply fascinating, require new ways of thinking. Collaborations that span across nations and disciplines provide an array of methods and techniques, each one a potential key to unlocking a deeper understanding of the universe's fabric. By combining perspectives from different scientific traditions, researchers are better equipped to address the intricacies of these fields, contributing to both our grasp of cosmic processes and to the very methods used in scientific inquiry itself. Moreover, such international partnerships don't merely advance knowledge, they also cultivate goodwill and build bridges between countries, offering a rare opportunity for diplomacy through science. In a world often divided by political boundaries, scientists united in their shared quest for understanding the universe can transcend national and ideological divides. This process strengthens not just academic discourse, but also the global scientific community, underscoring a common humanity fueled by a shared sense of wonder and curiosity about the cosmos. As humanity embarks on the pursuit of knowledge beyond the observable universe, we are faced with profound challenges, but also with equally profound opportunities. At the heart of these challenges is a desire to deepen our comprehension of the universe's most fundamental structures. One of the primary objectives of modern cosmology is to understand the nature of dark energy and dark matter. Together, these mysterious entities constitute approximately 95% of the universe's total mass energy content. Despite their immense significance, they remain among the most elusive and poorly understood components of the cosmos. By prioritizing research that seeks to unravel these enigmas, scientists can begin to piece together a more coherent framework of the universe's mechanics, both at the grand scale of galaxies and on the microscopic level. Equally important is the pursuit of knowledge surrounding cosmic inflation and the theory of the multiverse. The theory of cosmic inflation suggests that just moments after the Big Bang, the universe underwent a rapid expansion, stretching space-time at a speed faster than the speed of light. This expansion may have set the stage for the uniform distribution of galaxies that we observe today. However, understanding the exact conditions of this inflationary period could also provide crucial insights into whether our universe is merely one among many. Each of these universes, if they exist, could possess its own unique physical laws and constants, leading to the possibility of entirely different forms of existence. Such ideas force us to question not only the nature of the cosmos, but the very essence of reality itself. Fostering interdisciplinary collaboration is another crucial element in this intellectual pursuit. The exploration of phenomena that extend beyond the visible universe intersects with a broad range of academic fields, including mathematics, philosophy, and even computer science. Fields like computational modeling, for instance, provide powerful tools for simulating potential cosmic events and testing hypotheses. By merging these disciplines, researchers can enhance their ability to predict, test, and ultimately understand phenomena that have yet to be directly observed. For example, through the use of innovative technologies, such as state-of-the-art telescopes and advanced computational algorithms, scientists are able to refine their theories and extend the limits of what we can know about the universe. By embracing cutting-edge tools and methodologies from various fields of expertise, the global scientific community can develop more robust models to explain the most elusive and perplexing phenomena of existence. However, it is not only the scientific community that benefits from these collaborations. Communicating the significance of these cosmic frontiers to the general public is equally important. Many of the concepts at the forefront of cosmological research, such as dark matter, dark energy, and the multiverse, are deeply abstract and challenging for the public to fully grasp. As a result, it is essential for scientists and educators to make these ideas more accessible by explaining them in relatable terms. Through outreach efforts, the wider public can become more engaged with scientific progress, fostering greater interest and support for endeavors that seek to unravel the universe's mysteries. This engagement also helps to cultivate the next generation of scientists and thinkers who will continue to expand the frontiers of human knowledge and perhaps even unlock answers to questions that currently lie just beyond our reach. In recent years, citizen science has emerged as a powerful tool in advancing the exploration of cosmic anomalies at the edges of the known universe. By tapping into the enthusiasm and curiosity of everyday individuals from across the globe, citizen science initiatives allow ordinary people to contribute to groundbreaking discoveries. These volunteers, with little more than a computer and an internet connection, have made significant contributions to the field of astronomy, especially in terms of classifying distant galaxies, identifying exoplanets, and reporting unusual celestial events. The sheer volume of data produced by modern astronomical surveys is staggering. Large telescopes and space observatories regularly generate enormous data sets that are simply too vast for professional scientists to analyze alone. By involving citizen scientists, these projects can process and analyze this data far more quickly, enabling researchers to spot patterns or anomalies that might otherwise have gone unnoticed. For instance, volunteers might help identify potential supernovae, detect signs of dark matter, or even discover entirely new types of cosmic phenomena. In some cases, citizen scientists have been instrumental in sorting through the images captured by space telescopes, helping researchers identify previously unknown galaxies or unusual light patterns that could signal new discoveries. The contributions of these non-professional researchers have not only expanded the reach of scientific inquiry, but have also helped build a global community of individuals who are directly involved in the search for answers to the universe's most profound mysteries. By leveraging the collective power of volunteers, citizen science projects offer a unique way to accelerate the pace of discovery and engage a wider audience in the excitement of scientific exploration. Through their efforts, ordinary people can participate in the grand adventure of understanding the universe, contributing to the collective effort of humanity's quest for knowledge at the farthest reaches of space. The collective intelligence of countless volunteers working together can significantly improve the reliability of scientific observations. When citizens actively engage in cross-referencing data and verifying results, they help ensure the accuracy and validity of findings, especially when dealing with unusual signals or cosmic anomalies. This collaborative approach strengthens our understanding of the universe, creating a richer, more robust scientific knowledge base. But this is not just about enhancing the data. It also fosters a deep personal connection to the cosmos. People around the world from various walks of life become part of this scientific journey, contributing to discoveries that ultimately help us better comprehend the vast mysteries of the universe. What makes citizen science particularly valuable is that its impact extends far beyond just data collection. Many participants take the extra step of sharing their insights, publishing blogs, writing articles, or presenting their findings at local science fairs. By doing so, they spark public interest and educate others about the wonders of astronomy and cosmology. In this way, citizen science becomes more than a tool for discovery. It transforms into a platform for building a global community of learners, explorers, and science enthusiasts. This community of passionate individuals, united by a shared curiosity and sense of wonder, helps collectively deepen humanity's understanding of the cosmos and its unfathomable complexities. By channeling the collective curiosity of people from all corners of the world, citizen science plays a pivotal role in charting the vast uncharted regions of space and unearthing the secrets hidden within. Astrophysics, a field teeming with cutting-edge research, strives to answer some of the most profound questions we have about the universe. Among the most promising areas of research are the enigmatic concepts of dark matter and dark energy. These phenomena together account for a staggering 95% of the universe's total mass and energy. Yet we can only observe a tiny fraction of this hidden content. Through advanced experiments and astronomical observations, scientists are working diligently to directly detect dark matter particles. Such a breakthrough would not only validate their existence, but could also unlock new knowledge about their properties, potentially revealing groundbreaking insights into the very structure of the universe. Another captivating area of research that sheds light on cosmic mysteries is the study of gravitational waves. Predicted by Albert Einstein more than a century ago, these ripples in the fabric of spacetime were first detected with certainty in 2015. Observatories like the Laser Interferometer Gravitational Wave Observatory, LIGO, are now positioned to observe cataclysmic events such as the merger of black holes or neutron stars. Each detection offers scientists an unprecedented window into the behavior of these extreme cosmic entities and the fundamental physics that govern the universe's behavior. These observations not only deepen our understanding of the cosmos, but also challenge our perceptions of space and time itself. Astrobiology, the study of life beyond Earth, plays a crucial role in investigating cosmic anomalies. The quest to understand whether life exists elsewhere in the universe propels many areas of astrophysical research. Scientists are drawn to study Earth's most extreme environments, places where life thrives under conditions that could mirror those found on other planets. By learning how life adapts to such extreme environments, researchers hope to broaden the search for extraterrestrial life. The insights gained from studying Earth's extremophiles, organisms that thrive in hostile conditions, could lead to the discovery of life in places we never imagined possible. Furthermore, advancements in technology, such as the development of artificial intelligence, are playing a vital role in this search. AI's ability to analyze massive datasets generated by telescopes can reveal subtle patterns and anomalies that might have been previously overlooked. With this technology, scientists can ask new questions and explore uncharted territory, deepening our understanding of the universe's mysterious behavior. Each area of research, whether it involves dark matter, gravitational waves, or the search for life beyond Earth, not only promises to uncover the hidden truths behind cosmic anomalies, but also opens up the possibility for breakthroughs that could radically transform our understanding of everything we know. Interdisciplinary approaches have become essential in tackling these complex problems, with different scientific fields contributing unique perspectives to the study of space anomalies. For example, while astrophysics traditionally focuses on the physical laws that govern celestial bodies, fields like biology and psychology offer important insights into the possibility of life existing beyond our planet, as well as how we humans interpret the vast expanse of the cosmos. This interdisciplinary collaboration enriches the scientific process, allowing researchers to examine complex phenomena from a multitude of angles, increasing the depth and breadth of our understanding. Consider, for instance, the relationship between astronomy and computer science. Advanced algorithms and machine learning models have become indispensable tools in the analysis of vast datasets collected by telescopes. These technologies help astronomers sift through an overwhelming amount of data, identifying unusual signals like fast radio bursts, which continue to challenge researchers' understanding of the universe. By leveraging computational methods, astrophysicists can uncover patterns that would otherwise remain hidden, paving the way for new questions and potentially groundbreaking discoveries. Moreover, engineering plays an integral role in the study of cosmic anomalies. Innovations in instrument design, such as more sensitive detectors and adaptive optics, have dramatically improved our observational capabilities. These advancements allow scientists to capture much more precise measurements of celestial phenomena, revealing intricate details that could point to previously unseen physical processes. When engineers, physicists, and astronomers collaborate, they create a powerful synergy that accelerates the pace of discovery and opens new frontiers in our quest to understand the universe. The future of space exploration and the study of cosmic anomalies is therefore not just in the hands of professional scientists, but in the collective efforts of a global community. Through citizen science, interdisciplinary collaboration, and the use of cutting-edge technology, we are inching closer to answering some of the most profound questions of our time, questions that just a few decades ago seemed like mere science fiction. Incorporating social sciences into the exploration of the universe introduces an additional layer of understanding, offering a crucial perspective on how humanity perceives, interprets, and reacts to the vast cosmos. This integration can be pivotal in shaping how scientists communicate their discoveries. For example, the narrative surrounding the discovery of a new black hole is just as essential as the scientific data that defines its physical attributes. The way the public engages with such findings can foster a culture of curiosity, inspiring future generations to continue the pursuit of knowledge. When diverse disciplines intersect, we can shed a brighter light on the mysteries of the cosmos, expanding not only our comprehension of the universe, but also our understanding of our own place within it. As we stand at the cusp of monumental advancements, artificial intelligence, AI, is poised to revolutionize the exploration of space in remarkable ways. One of AI's most compelling contributions is its ability to process and analyze vast amounts of data at remarkable speeds. With the increasing power of telescopes and observatories, astronomers are gathering an overwhelming wealth of cosmic data. AI can sift through this immense stream of information with unparalleled efficiency, identifying patterns and anomalies while filtering out irrelevant noise that would be impossible for humans to process manually. AI also enhances our ability to explore celestial bodies and phenomena with precision. For instance, AI algorithms are now used to classify exoplanets by detecting subtle variations in the light curves from distant stars. These patterns can reveal the presence of atmospheres that could potentially support life. By automating this identification process, AI accelerates research, allowing scientists to focus their efforts on the most promising leads. Furthermore, AI can optimize resource allocation, ensuring that space missions are directed toward the most intriguing and scientifically valuable targets. In the realm of robotics, AI plays a critical role in missions to unexplored regions of our solar system. Autonomous drones and rovers equipped with AI can make real-time decisions as they traverse the alien landscapes of distant planets and moons. These systems can adapt to unforeseen challenges, such as navigating rough terrain, and make autonomous choices about where to go next. This capability eliminates the lag time inherent in relying on Earth-based commands, allowing for more efficient data collection and experimentation. Artificial intelligence is also transforming the field of simulations and theoretical modeling. By enabling researchers to construct complex models of cosmic phenomena, AI allows scientists to test hypotheses about the origins, evolution, and behavior of the universe on scales previously thought to be out of reach. As the boundaries of our knowledge continue to expand, the collaboration between human ingenuity and artificial intelligence holds the promise of unlocking even greater cosmic mysteries, inspiring future generations to dream big and reach for the stars. Exploring the universe has always required substantial financial resources, and as our ambitions for space exploration grow, so too does the need for innovative funding models. One promising approach is the establishment of public-private partnerships. These collaborations between government agencies and private aerospace companies leverage the strengths of both sectors, combining governmental support with private sector innovation. Such partnerships can significantly reduce the financial barriers to ambitious space missions, providing the necessary funding to make groundbreaking endeavors possible. Another intriguing model is crowdfunding, which has gained significant traction in recent years across various sectors. By allowing the general public to contribute small amounts of money to a cause, researchers can pool substantial funding for specific projects. This approach democratizes the funding process, inviting the public to become active participants in the scientific journey. Moreover, it fosters greater public interest in astronomy and cosmology. Projects with clear, imaginative goals, such as missions to capture images of distant exoplanets or the development of advanced telescopes, are particularly well suited for crowdfunding campaigns, as they can captivate the imagination of a wide audience. Additionally, governments could consider utilizing science prizes to stimulate innovation in the field of cosmology. Offering substantial financial rewards for achieving specific scientific milestones or breakthroughs would provide an incentive for researchers to pursue ambitious projects. The competitive nature of such prizes could encourage collaboration and foster the exchange of ideas across teams from around the world, all vying for recognition and financial backing. A more sustainable funding model could involve combining grants with alternative revenue streams, such as educational content or science tourism. By attracting visitors to facilities like planetariums and observatories, and offering public lectures and workshops, institutions could create a steady stream of income to support their research endeavors. This model not only generates ongoing funding, but also engages the public in the quest for knowledge, inspiring the next generation of scientists eager to uncover the secrets of the universe. Academia stands at an exciting crossroads as the frontiers of scientific inquiry expand into new and previously uncharted territories. Researchers are increasingly being encouraged to explore anomalies that challenge existing frameworks, and this shift calls for a thoughtful and adaptive response from educational institutions. Preparing for these evolving priorities means cultivating a culture that embraces curiosity, interdisciplinary collaboration, and flexibility in research methodologies. At the heart of this transformation, academic institutions must nurture an environment that fosters innovative thinking. This involves incentivizing researchers to explore unconventional hypotheses, especially those that challenge established scientific paradigms. By promoting the questioning of the status quo, universities and research centers can encourage exploration into phenomena that currently defy understanding, whether it's the mysteries of dark matter, the peculiarities of quantum particles, or the complex dynamics of cosmic evolution. Workshops, seminars, and targeted funding opportunities focused on anomaly-driven research would help stimulate intellectual dialogue and foster a spirit of inquiry. As we venture into the unknown, it's this blend of creativity, collaboration, and adaptability that will propel scientific progress, leading us closer to understanding the deepest mysteries of the cosmos and our place within it. Interdisciplinary collaboration is crucial when addressing the complexities surrounding the anomalies of our universe. These anomalies, often perplexing and elusive, span various scientific domains, from physics and biology to philosophy, each of which offers a distinct approach to understanding these enigmatic phenomena. Academia must prioritize fostering partnerships across disciplines, forging alliances that blend different skill sets and perspectives. In doing so, new avenues of discovery can be explored, as researchers from diverse backgrounds bring their unique insights to the table. This collaborative framework encourages the exchange of ideas, leading to the development of novel methodologies that break free from traditional academic boundaries. At the core of this interdisciplinary approach is the need for a forward-thinking curriculum. It's not enough to simply educate students in the established technologies and theories of today. Institutions must prepare the next generation of thinkers and researchers for the unknown. By embracing emerging fields such as astrobiology, neuroethics, and quantum computing, academic programs can provide students with the tools and knowledge to tackle questions that have yet to be answered. Moreover, fostering critical thinking and problem-solving abilities ensures that future scientists are not only capable of advancing existing knowledge, but also of pioneering new approaches to the great unknowns that lie ahead. Academia's role extends beyond teaching. It shapes the future of scientific discovery. As institutions equip students with the knowledge and skills needed to navigate uncharted territories, they position themselves as leaders in groundbreaking research. The outcomes of this research, new understandings, new technologies, have the potential to reshape not only our view of the universe, but also our place within it. The lessons drawn from historical failures in cosmic exploration provide invaluable insights that can guide future missions. Looking back at past space exploration efforts that fell short of their goals, we often find that the failures were not solely due to technical limitations, but rather the lack of cooperation or insufficient understanding of the environments in which space probes operate. Take, for example, the Mars Climate Orbiter mission, which was lost due to a critical failure in units of measurement. This incident underscores the importance of ensuring that all team members from various fields and institutions are aligned in their understanding and application of standards and protocols. It is essential to develop systems that are not only technically sound but also harmonized across all components of a mission. In many cases, the success of an exploration mission hinges on the smallest details that require collective attention and precision. Moreover, the tragic loss of the Space Shuttle Challenger is a sobering reminder of the importance of rigorous testing and validation. The Challenger disaster was not simply a failure of engineering, but a consequence of overlooking crucial safety procedures under the pressure of tight deadlines. This event serves as a stark warning. No deadline should ever be prioritized over the thorough assessment of potential risks. A culture that emphasizes comprehensive testing, even if it means delaying the timeline, is essential. Such a culture not only protects lives but also conserves valuable resources, ensuring that the pursuit of knowledge does not come at an unnecessarily high cost. International collaboration also plays a pivotal role in cosmic exploration. In previous missions, the combined resources and knowledge of different countries have significantly advanced our understanding of the cosmos. However, working across borders and institutions introduces its own set of challenges, particularly in terms of communication and cultural differences. The story of the Hubble Space Telescope is a testament to the power of global collaboration. Despite facing initial setbacks, including a flawed mirror that delayed its scientific potential, the ongoing teamwork between international teams turned the Hubble into one of the most important tools for cosmic exploration, revealing insights into the very fabric of our universe. Embracing failure as a stepping stone rather than a setback is another critical lesson. Every mission, whether successful or not, contributes to our understanding of space and exploration. Failures, in particular, provide valuable data and insights that can help future missions avoid similar pitfalls. By cultivating resilience in the face of failure, researchers and explorers develop the adaptability needed to overcome obstacles and move closer to solving the mysteries of the universe. The next wave of cosmic exploration will undoubtedly benefit from the lessons of the past. As humanity's understanding of space evolves, our approach to exploration will be shaped by enhanced collaboration, technological innovation, and a more nuanced understanding of the challenges we face. The mysteries of the universe, those cosmic anomalies that perplex and fascinate us, may one day yield their secrets to the combined efforts of a united scientific community ready to push the boundaries of knowledge. Cosmic anomalies, those strange and mysterious phenomena scattered throughout the universe, have long fascinated scientists and laypeople alike. Objects such as black holes, neutron stars, and dark matter represent the pinnacle of the universe's complexity, phenomena so profound that they challenge our very understanding of reality. The sheer scale and diversity of these anomalies reveal that the universe operates on principles far beyond our daily experiences. The complexity of these cosmic phenomena serves as a reminder of humanity's relatively brief existence in the grand expanse of time. The study of these anomalies encourages reflection on the fragile and unique nature of our existence. Take, for instance, the fact that Earth resides in a narrow, habitable zone around a star that, in the grand scheme of the cosmos, is relatively small and unremarkable. This delicate positioning is not only a testament to the precariousness of our existence, but also to the fine-tuned conditions required for life to flourish. In contrast, events like gamma-ray bursts or supernovae, cataclysmic explosions that can obliterate entire star systems, serve as a reminder of the destructive potential that lurks within the universe. Yet, against all odds, Earth remains a haven of life, thriving amidst this vast and unpredictable cosmos. This paradox, the simultaneous existence of chaos and life, raises profound questions about the nature of our place in the universe. In a cosmos teeming with potentially deadly forces, how is it that life persists on our tiny, fragile planet? Such reflections can help us appreciate the rarity and fragility of our situation, shedding light on the importance of preserving the delicate balance that sustains life on Earth. The study of cosmic anomalies thus not only deepens our understanding of the universe, but also fosters a sense of humility and gratitude for the rare and remarkable conditions that allow life to thrive. As we delve deeper into the vast expanse of cosmic phenomena, we begin to confront profound and timeless questions about our origins and destiny. The study of anomalies in the universe provides us with vital insights into the conditions that led to the formation of stars and galaxies, which ultimately laid the groundwork for the creation of the very building blocks of life as we know it. This exploration of the cosmos pushes us to reflect on humanity's place in the universe, inviting us to consider our responsibility in preserving our planet and exploring our cosmic neighborhood. It reinforces the idea that our understanding of the universe can serve as a guide in shaping how we protect and cherish Earth. The knowledge we gain from studying cosmic anomalies goes far beyond enriching scientific inquiry. It profoundly enhances our worldview. Each discovery, whether about the origins of stars or the nature of distant galaxies, challenges us to look beyond the mundane, to understand that every twinkling star and every swirling galaxy is a reminder of our deep and ancient connection to the cosmos. In the face of such vastness, humanity's existence feels like a fleeting yet remarkable chapter in an ongoing cosmic story that stretches far beyond our own lifetimes. It's a narrative that invites curiosity and continuous exploration, inspiring us to seek answers about the universe and perhaps our very purpose within it. Consider the spark that ignites a lifelong fascination with the mysteries of the universe. For many, this fascination begins in childhood, with the first glimpse of the night sky. Imagine a warm summer evening, the air thick with the scent of earth and the sound of distant crickets. A young child gazes up in wonder at a blanket of stars, each one flickering against the vast, dark canvas above. In that moment, questions begin to stir. What are those stars? How far away are they? What secrets do they hold? These simple questions often serve as the catalyst for a deeper, lifelong exploration of the cosmos. As we grow older, experiences continue to fan the flames of this cosmic curiosity. Perhaps it's a visit to a planetarium where vivid visualizations of distant galaxies and swirling nebulae come to life in front of our eyes. The scale of the cosmos becomes overwhelming in such moments. Some galaxies lie billions of light years away, their light traveling across the immense emptiness of space to finally reach our eyes. This transforms what were once abstract concepts of distance and time into something tangible, something profoundly real and awe-inspiring. Such moments of discovery often unfold through documentaries or discussions with passionate astronomers. The opportunity to understand the nature of black holes and their ability to warp space and time is exhilarating. Could these enigmatic objects hold the answers to fundamental questions about the universe? Each snippet of knowledge acts as a thread, weaving together a vast and intricate tapestry of understanding, deepening our curiosity about the cosmos. From the awe-inspiring moments of childhood wonder to the enlightening experiences of adulthood, life's journey is marked by these sparks of curiosity. Each one illuminates a path toward exploration, urging us to continuously seek knowledge about the universe and its myriad mysteries. As we embark on this quest for understanding, the beauty and complexity of the universe unfold before us. Despite its vastness, there's a profound sense of connection between the cosmos and our very existence. And so, personal beliefs often shape how individuals perceive what lies beyond the observable universe. These beliefs, whether rooted in culture, religion, philosophy, or personal experience, provide a lens through which we interpret the profound mysteries of existence. For some, religious beliefs offer a sense of purpose and meaning. Those who adhere to a particular religious framework might envision an afterlife or the creation of the universe by a divine entity. This perspective often brings with it the notion of a purposeful creation, a universe with order, balance, and meaning. Conversely, those who lean more toward scientific perspectives might ponder the implications of multiverse theories or the potential existence of other dimensions. For them, the universe is not a created entity, but an ever-evolving system governed by the laws of physics and filled with infinite possibilities. This scientific lens drives curiosity about phenomena like dark matter, black holes, and the very fabric of space-time, igniting speculation about parallel universes and realms beyond our perception. Cultural narratives also play a powerful role in shaping these beliefs. Many indigenous cultures, for instance, emphasize the interconnectedness of humanity with the cosmos. Native American spirituality, for example, often sees the universe as a living entity, brimming with spirit and consciousness. This view contrasts with the more detached, scientific perspectives that often suggest that the universe is a cold, mechanical system. Instead, such narratives foster a deep sense of unity with the cosmos, encouraging people to view the universe not as an external force to be understood, but as something deeply relational and alive. This intricate dance between belief and understanding creates a rich and varied tapestry of perspectives, each shaped by an individual's unique upbringing, education, and introspection. As we seek answers to the age-old question of what lies beyond our universe, our personal beliefs guide us. These beliefs provide both comfort and a framework for exploration, whether that exploration is grounded in the scientific method or in spiritual reflection. In either case, the drive to understand what lies beyond our observable world remains one of humanity's most compelling pursuits. The understanding of the universe has undergone remarkable transformations over the centuries, often driven by advancements in technology and shifts in scientific thought. Ancient civilizations, for instance, largely perceived the cosmos through a geocentric lens, believing that Earth stood at the center of everything. However, this worldview began to shift dramatically in the 16th century with the work of Copernicus, who proposed that the Sun, not Earth, was the center of our solar system. This radical shift laid the groundwork for a more nuanced understanding of our place in the cosmos. The invention of the telescope revolutionized our understanding even further. Pioneers like Galileo Galilei and Johannes Kepler used this new technology to observe celestial bodies with unprecedented clarity. Their discoveries, such as the moons of Jupiter and the elliptical orbits of planets, fundamentally altered our understanding of motion in space. The development of Newtonian physics provided an even more sophisticated framework for understanding gravity and the forces at play in the universe, refining our understanding of the movement of celestial objects. The 20th century ushered in an era of truly extraordinary discoveries. Albert Einstein's theory of relativity, for instance, fundamentally changed how we view time and space, intertwining them in ways that had never been imagined before. The discovery of the expansion of the universe through the redshift of distant galaxies led to the Big Bang theory, which posited that the universe had begun from a singular point and has been expanding ever since. This theory reshaped our understanding of cosmic history and the vastness of existence. In recent years, the exploration of dark matter and dark energy has added another layer of complexity to our understanding of the cosmos. It is now believed that much of the universe is composed of these mysterious, invisible forces, which remain largely unknowable to our current scientific methods. Nevertheless, the development of advanced telescopes and observational instruments continues to unveil new phenomena, from exoplanets to gravitational waves. These discoveries prompt us to reflect on the origins of the universe and the potential for life beyond our planet, deepening our understanding of the cosmos with each new breakthrough. The quest for knowledge about the universe is not limited to the realms of science. Personal experiences, too, play a significant role in shaping how we reflect on our place in the cosmos. Perhaps it's during a peaceful hike on a quiet trail, surrounded by the gentle rustling of leaves and the cool touch of a breeze, that one feels a connection to something larger than oneself. Such moments of immersion in nature often provoke profound reflections on the interconnectedness of all life, evoking deep questions about existence and the purpose of human life. Likewise, experiences of joy and sorrow can also prompt us to contemplate the mysteries of the universe. The beauty of a sunset, with its colors melting into the horizon, may inspire thoughts on the fleeting nature of time. The sight of countless stars, many of which have existed for billions of years, may awaken a sense of humility and wonder about the vastness of existence. Personal loss, too, can drastically shift one's perspective, making questions about life, death, and the afterlife feel more urgent and poignant. Such experiences, the quiet moments in nature, the sense of awe at the night sky, the reflections brought on by both joy and sorrow, serve to remind us that our lives, though brief in the grand scheme of the universe, are intricately woven into the fabric of existence itself. They inspire us to continue seeking answers to the eternal questions about our origins, our purpose, and what lies beyond the universe. And in the process, they shape our relationship with the cosmos, drawing us ever closer to its infinite mysteries. Conversely, there are moments in life that can instantly stop us in our tracks, capturing our attention in ways we never expect. For example, standing in awe of a child's laughter or witnessing the birth of a new family member can light up our world, revealing the simple yet profound nature of joy and human connection. These experiences highlight a fundamental truth about existence, that both suffering and happiness are intertwined, coexisting in a delicate balance that shapes our understanding of what it truly means to be alive. In the quiet laughter of a child, or the tears of joy at the birth of a new family member, we find fragments of something deeply meaningful. These moments echo the age-old questions of existence, prompting us to reflect on what it means to be human. It is in these shared human experiences, whether profound or mundane, that we discover the threads of meaning that resonate with us all. They serve as reminders of our common journey, a quest for understanding in a universe that often feels both vast and unfathomable, yet somehow intimately tied to our personal stories. This connection extends beyond our interactions with one another and reaches into the natural world, which profoundly influences the way we perceive the cosmos. Our environment serves as a lens, shaping how we interpret the unpredictable phenomena happening beyond our planet. Whether it's the vibrant hues of a sunrise, the rhythmic motion of ocean waves, or the majestic dance of clouds across the sky, nature reveals to us the intricate workings of the universe, igniting a sense of awe and curiosity about the world around us. These natural experiences, deeply rooted in the cycles of life on Earth, invite us to look beyond our planet with wonder. They encourage us to see cosmic anomalies like black holes, supernovae, and cosmic microwave background radiation, not just as abstract scientific concepts, but as integral parts of a much larger, interconnected system. The more we engage with nature, the more we are prompted to ask deeper questions about our existence and our place within the vast expanse of the universe. Witnessing the annual migration of birds or the blooming of flowers each spring can stir thoughts about cycles, evolution, and the unseen forces that govern life itself. These observations and reflections bring clarity to the delicate interplay between order and chaos, a theme that resonates both on Earth and in the cosmos. Just as ecosystems demonstrate resilience and adaptability, so too does the universe confront endless transformations and disruptions. Natural phenomena such as a stormy night or a sunset can serve as analogies for cosmic events. A thunderstorm might make us think of the tumultuous processes in distant galaxies, where stars are born, live, and die in spectacular explosions. Far from being isolated, cosmic anomalies have a way of echoing the rhythms of life on Earth, creating a bridge between the intimate and the vast. This connection between the natural world and the universe encourages us to embrace both. It inspires a sense of stewardship over our planet, urging us to care for the Earth while simultaneously fostering a yearning to explore the great mysteries that lie beyond. Through this lens, cosmic anomalies become more than mere phenomena to be studied. They transform into shared experiences that reflect the depths of human understanding and curiosity. They call us to look outward with the same wonder we feel toward the beauty of Earth, compelling us to explore the unknown while continuing to cherish the intricate tapestry of life that surrounds us. This duality, the connection to the natural world and our drive to comprehend the cosmos, enriches our understanding and appreciation of both realms. Our personal experiences often serve as the bedrock upon which our fascination with astrophysics is built, weaving together threads of curiosity that lead us to explore the universe in greater depth. For many, this journey begins with a single, awe-inspiring moment. Perhaps gazing at a starry sky on a clear night, witnessing a total solar eclipse, or being captivated by a science fiction film that sparks the imagination. These early encounters with the cosmos awaken a sense of wonder and prompt us to ask fundamental questions about the nature of existence, the stars, and the origins of the universe itself. As individuals continue to grow, their interests in the cosmos are often shaped and deepened by new experiences. A visit to a planetarium, an astronomy camp, or even a conversation with an expert can open the door to new knowledge, enriching one's understanding of celestial phenomena. Learning about the life cycles of stars, the mysteries of black holes, or the infinite expanse of space can turn fleeting curiosity into a dedicated passion. With each new discovery, the cosmos becomes less of an abstraction and more of an accessible, awe-inspiring realm that invites us to continue seeking answers to the deepest questions about our existence. Engaging with knowledgeable mentors, whether teachers, scientists, or other experts, offers invaluable guidance, serving as a vital catalyst that fuels the enthusiasm of aspiring minds. This kind of mentorship doesn't just impart technical knowledge, it ignites a passion for learning that encourages deeper exploration into the mysteries of the universe. For those lucky enough to have such figures in their lives, the inspiration to pursue astrophysics or any scientific field often comes naturally, as mentors create an environment where curiosity is nurtured and further study becomes a natural progression. Personal background also plays a significant role in shaping one's path to the stars. Those who grow up in communities where discussions about the universe are commonplace often find their curiosity about science nurtured from a very young age. In such households, questions about the cosmos are not out of place. They are part of the daily dialogue. For others, however, the journey may begin later in life, sparked by reading a book, attending a lecture, or simply being introduced to a new idea that piques their curiosity. Each individual's path to astrophysics is uniquely their own, influenced by the environment they grow up in, the experiences they have along the way, and the moments that spark a deep, unrelenting curiosity. These formative experiences, whether an inspiring event, an influential mentor, or even a random encounter with a thought-provoking concept, can all act as powerful catalysts that sustain a lifelong commitment to exploring the universe. Ultimately, these personal experiences are the threads that weave us into the fabric of the cosmos. Our fascination with the universe, with the stars, and with the forces that govern the very fabric of reality transcends mere intellectual curiosity. These wonders, black holes, neutron stars, and the enigmatic dark matter, are not only the subject of scientific inquiry, they captivate the public imagination as well. These cosmic phenomena challenge our fundamental understanding of the universe and, in many ways, offer a rich tapestry for storytelling. When we share the stories of how scientists unravel these mysteries, we do more than just relay scientific data. We share the human experience of discovery, tapping into something deeply personal and universally relatable. These stories resonate with our shared curiosity about the cosmos and our intrinsic desire to uncover the hidden truths of existence. Through storytelling, complex scientific concepts like black holes become more accessible. The narrative might frame a black hole not just as an astronomical phenomenon, but as a symbol of transformation, loss, or the unknown, a mirror to our own experiences with the mysterious and the unexplained. The concept of a black hole, where the known laws of physics break down into utter chaos, evokes a sense of awe and mystery that touches on something much deeper than just science. It connects to our own personal fears, challenges, and experiences with the unknown. The question of what lies at the edge of a black hole, where even light cannot escape, invites us to reflect on the boundaries of human knowledge and existence. This connection between scientific facts and personal reflection fosters engagement with the broader narrative of discovery, encouraging us to ponder our beliefs about creation, existence, and the very nature of reality. By incorporating personal experiences, cultural narratives, and the complexities of human emotion, the stories we tell about cosmic anomalies not only enrich our understanding of science, but also deepen our personal beliefs. These tales invite dialogue and exploration, stirring the imagination and prompting us to ask profound questions about our place in the vast universe. What is our role in the grand cosmic narrative? How do our beliefs shape the way we understand phenomena beyond our immediate experience? The interplay between science and personal narrative enhances both fields, inspiring a collective journey into the mysteries of the cosmos. Confronting the unknowns of the universe sparks a powerful mix of emotions. The sheer vastness of space, with its countless mysteries and unanswered questions, instills a sense of awe and wonder that stretches beyond our daily experience. When we gaze at a star-filled sky, or when we attempt to grasp the nature of dark matter, we are reminded of our tiny yet profound place in the cosmos. This perspective, which encourages both curiosity and respect for the intricate workings of the universe, also brings with it a sense of humility. The realization that so much remains undiscovered evokes a vulnerability, reflecting the human condition, a relentless quest for knowledge, coupled with the undeniable limitations of our understanding. This duality, the awe of discovery and the humility of uncertainty, fuels our desire to explore further. Each unanswered question about black holes, dark matter, or the origins of galaxies acts as a call to adventure, a challenge to push the boundaries of what we know. The emotional response to these mysteries, combining excitement and trepidation, becomes a driving force for scientific inquiry. The challenge of comprehending multidimensional space or imagining extraterrestrial life can feel overwhelming, yet it does not deter us. Rather, it ignites our passion, pushing us to seek deeper insights with the hope that, despite the uncertainty, we will one day uncover the answers. Grappling with these unknowns cultivates a unique emotional experience, a mixture of fascination, fear, and wonder. It reminds us of our intrinsic connection to the cosmos and inspires generations of thinkers, explorers, and dreamers. As we continue to probe the universe's vast and mysterious depths, we not only expand our scientific knowledge, but also our understanding of ourselves. The pursuit of these cosmic anomalies offers profound insights into what it means to be human, confronting our limitations and awakening a desire to understand our place within the grand expanse. In this journey, we often find ourselves reflecting on the very nature of existence, the essence of identity, and the search for meaning. As we explore the mysteries of phenomena such as black holes, dark matter, or the possibility of extraterrestrial life, we are not just uncovering physical mysteries. We are grappling with fundamental questions about the universe and about ourselves. These explorations compel us to rethink our concepts of time, space, and reality, challenging our worldview and pushing the boundaries of our intellectual capacity. At the heart of these explorations is a reminder that while we are capable of remarkable intellectual feats, we are also creatures driven by curiosity, a longing for comprehension that transcends the physical limits of our knowledge. The cosmic anomalies we chase serve as metaphors for our hopes, fears, and aspirations. In this pursuit, we acknowledge that our understanding of the universe is constantly evolving, just as our place in it continues to shift. The mysteries of the cosmos compel us to embrace the unknown, to spark creativity and innovation, and to cultivate a deeper appreciation for life and the shared human experience. By seeking answers to the questions posed by these enigmas, we reinforce our interconnectedness, not just with one another, but with the universe itself. In this grand journey of discovery, we realize that each unanswered question is not an obstacle, but a beckoning to a new adventure. It is through this shared journey, this collective quest to understand the infinite complexities of life and the cosmos, that we grow and evolve as a species. The enduring mysteries at the very edges of the universe, including the strange phenomena that challenge our most fundamental beliefs about the cosmos, are not just scientific questions. They are deeply philosophical inquiries that stir our imaginations, challenge our assumptions, and ultimately invite us to reflect on our place in this vast and ever-expanding universe. The nature of dark energy remains one of the most profound and enigmatic questions in modern cosmology. Believed to drive the accelerated expansion of the universe, It plays a critical role in shaping the future of the cosmos, yet it eludes our understanding. Dark energy accounts for nearly 70% of the universe, but despite its vast influence, we have no clear idea of its true composition or origin. This absence of understanding raises fundamental questions. What is dark energy? How does it behave, and why is it such an elusive force? These questions not only challenge our scientific models, but also force us to confront the limits of our knowledge and the mysteries that lie ahead. Equally puzzling is the nature of cosmic voids, vast expanses of space that seem almost empty, containing very few galaxies. These voids are not just random gaps in the fabric of the universe, they appear to play a central role in shaping the large-scale structure of the cosmos. Their presence raises deep questions about the distribution of matter and energy in the universe. What caused these voids to form? How do they influence the behavior of galaxies and the overall evolution of the universe? Understanding the dynamics of cosmic voids could unlock important insights into the formation of cosmic structures and the behavior of dark matter, a mysterious substance that seems to permeate the universe but remains invisible to current instruments. Another question that fascinates scientists is the boundary of the observable universe. This boundary is not a physical edge, but a limit dictated by the speed of light and the age of the universe. Essentially, it marks the farthest we can see. Beyond that, the light has not had time to reach us since the beginning of the cosmos. But what lies beyond this horizon? Is there a vast unseen expanse filled with galaxies, stars, and other cosmic phenomena? Or could we be perched on the edge of an entirely different, perhaps even larger, cosmic landscape? Could there be parallel universes or dimensions that remain hidden from our perception? These questions challenge the very limits of our understanding and open the door to new possibilities in cosmology. The concept of cosmic inflation, the rapid exponential expansion of space in the very early universe, adds another layer of complexity to our exploration. What triggered this dramatic growth, and how did it shape the universe we observe today? Cosmic inflation theory suggests that in an infinitesimally short period of time, the universe expanded faster than the speed of light, smoothing out the distribution of matter and energy across vast distances. But the cause of this rapid expansion remains a mystery. Understanding what triggered inflation could help us answer deeper questions about the origin and structure of the universe. Each of these unanswered questions represents a frontier of human knowledge. They not only highlight the gaps in our understanding, but also fuel the passion of scientists and enthusiasts alike, propelling them forward in the quest for deeper cosmic truths. The pursuit of these answers is not just about adding knowledge to our scientific database. It is a fundamental part of the human experience, our desire to explore the unknown. Throughout history, exploration has been a central driver of human progress. It has pushed us to expand not only our geographical boundaries, but also our intellectual horizons. Whether it's venturing into the depths of the oceans, exploring distant planets, or gazing into the farthest reaches of space, the drive to discover has always been a part of who we are. But exploration is not just about finding new lands or new cosmic phenomena. It is equally about discovering something deeper within ourselves. Every new discovery forces us to confront our limitations and expand our understanding of who we are in the universe. These moments of exploration invite us to reflect on our collective identity, to question our societal values, and to redefine our role within the larger tapestry of existence. The Apollo missions, for instance, did more than just advance our knowledge of the moon. They showcased the remarkable capacity of humanity to unite in the pursuit of a common goal. The innovations, collaborations, and determination demonstrated during these missions serve as a testament to human ingenuity and resilience. It's a reminder that when we are driven by a shared vision, we are capable of achieving the extraordinary. Engaging with the unknown also stimulates introspection. The challenges faced during exploration, whether on Earth or in space, push us to examine not only our technological capabilities, but also our societal structures. When we encounter new cultures, ecosystems, or extraterrestrial environments, we are prompted to question what truly matters to us as a species. What are our priorities, and how do they shape the world we live in? This kind of reflection can lead to a deeper sense of global citizenship, fostering a greater awareness of the interconnectedness of all life and encouraging more responsible, sustainable practices for the future. As we explore distant worlds, we are also reminded of the fragility of life. Whether we are studying Earth's delicate ecosystems or searching for signs of life on distant planets, the more we learn, the clearer it becomes that life is a precious and rare phenomenon. Understanding this fragility brings a heightened awareness of the importance of protecting our planet and preserving the delicate balance that sustains all life. The knowledge we gain from these explorations can serve as a catalyst for global cooperation as we work together to address the pressing challenges facing humanity today, from climate change to social inequality. At its core, the journey of exploration is as much about personal transformation as it is about collective advancement. It reshapes our understanding of who we are, both as individuals and as a species. It teaches us humility in the face of the vastness of the universe and challenges us to broaden our perspectives in ways we never imagined. The universe, in all its complexity and grandeur, often surpasses our comprehension. But it is through the pursuit of understanding that we are able to uncover new truths, some that astonish us, others that humble us. As we dive deeper into the mysteries of the cosmos, we are confronted with a reality that is both awe-inspiring and humbling. The sheer scale of the universe, with its billions of galaxies and trillions of stars, makes our home planet seem incredibly small. This realization sparks a profound curiosity, a desire to understand not only the universe, but also our place within it. How did we come to be? What is our role in this grand cosmic drama? These are questions that echo throughout our exploration, driving us to seek answers even as we discover new mysteries. In our quest for knowledge, we are also confronted with the elegance and intricacy of the laws that govern the universe. From the forces of gravity that hold galaxies together to the strange and unpredictable behavior of subatomic particles, the universe operates according to rules that are both beautifully simple and wonderfully complex. These laws challenge our assumptions, pushing the boundaries of our understanding. Yet despite our best efforts, many questions remain unanswered. This is the essence of scientific exploration, not just discovery, but also the acceptance of mystery. It reminds us that the journey of exploration is as much about asking questions as it is about finding answers. And in that search for answers, we learn more about ourselves and the universe than we ever imagined possible. Studying the cosmos has revealed something profoundly deeper than mere curiosity. It has underscored the intricate interconnectedness of all things. The elements that form the very fabric of our being, carbon, nitrogen, and oxygen, were created in the cores of ancient, long-dead stars. These elements, which are not just vital to life, but to our existence itself, were scattered across the universe as those stars exploded, seeding the galaxies with the building blocks for life. In this way, we are intricately linked to the greater cosmos, our lives forever intertwined with the stars that came before us. This cosmic connection illuminates the idea that we are not isolated entities, but rather parts of a much larger, vast, and ever-evolving universe. Such a realization comes with a deep sense of responsibility. It propels us to reflect on the importance of understanding and caring for our own home, Earth, as an integral part of this vast cosmic family. The study of the cosmos, far from being an abstract or distant pursuit, inspires us to take better care of the world we inhabit. Our planet, like us, is but a fleeting moment in the grand timeline of the universe, and recognizing this can help us approach it with greater reverence. In this pursuit, cosmology does more than reveal the mysteries of the stars. It fosters an appreciation for the Earth itself and strengthens our awareness of the role we play within it. Through this lens, the very act of learning about the universe becomes an expression of stewardship and connection, urging us to protect and nurture the planet that sustains life. Furthermore, the journey of understanding the universe teaches us something invaluable: resilience in the face of uncertainty. The path of scientific progress is rarely straight. It is filled with dead ends, unexpected twists, and more questions than answers. Yet, it is precisely this uncertainty that propels us forward. The process of inquiry, with its inevitable setbacks, nurtures adaptability and patience. Embracing the unpredictability of discovery allows us to remain curious, persistent, and above all, open to the unknown. Each question, no matter how elusive, is an invitation to explore further, to seek deeper understanding, and to recognize that our pursuit of knowledge is not a race with a definitive end, but a continuous adventure. This journey is about the thrill of discovery itself, about the unexpected revelations that come when we least anticipate them. Imagine, for a moment, the opportunity to pose a question to an entity that exists beyond the observable universe. What would you ask? The thought alone invites a profound exploration of ideas that stretch the limits of human comprehension. What might it be like to inquire, what exists beyond the boundaries of what we can see? Or, how does your reality differ from ours? These questions resonate deeply within cosmology, where the observable universe is, quite literally, all that we can perceive, defined by the distance that light has traveled since the Big Bang, roughly 8 billion years ago. Beyond this point, our understanding fades into mystery. What lies beyond the furthest reaches of our observation? Perhaps other universes, dimensions, or realms that operate under entirely different physical laws. As we consider the expansion of the universe, accelerating at an ever-increasing rate, our minds are drawn to ponder realms and realities that lie beyond the grasp of our instruments. What if there are entities in these far-flung corners of existence that experience life in ways completely foreign to us? Life forms that may not perceive the three spatial dimensions and time in the way we do. Imagining their experiences, their nature, and their diverse realities forces us to reconsider everything we know about life and existence itself. Could it be that life, in such unknown corners of the universe, takes on forms and attributes we cannot yet begin to fathom? The contemplation of this question reaches far beyond the mere exploration of what exists out there. It beckons us to consider our own place in the grand scheme of things. Are we merely a fleeting anomaly in the vastness of time and space? Or do we play a crucial role in a grand universal tapestry? This question challenges us to rethink the very principles that govern existence and to push the boundaries of scientific inquiry. Whether the answers lead us to a deeper understanding of the physical structure of space, or they take us to realms that transcend the very essence of consciousness itself, this pursuit inspires limitless curiosity. It opens an endless horizon of thought, an invitation to journey into the unknown. Indeed, the mysteries of the universe ignite a boundless sense of wonder within humanity. Each time we gaze up at the night sky, we are not simply admiring the distant stars. We are contemplating the vastness of all that exists, pondering the origins of life, the nature of existence, and the possibility of worlds beyond our own. Every cosmic phenomenon, from the shimmering light of distant stars to the swirling, colorful spirals of galaxies, stirs something deep within us. It compels us to ask questions that challenge the very core of who we are. Who are we in the context of all this? What are we meant to understand from the infinitude of space? This innate curiosity is not just a philosophical endeavor. It propels real scientific exploration. It drives us to seek new discoveries, to understand the universe in ways that were once inconceivable. The concept of an expanding universe pushes us to reconsider the limits of our knowledge and to recognize that there is so much more yet to be discovered. For many, this is a deeply comforting thought. The idea that we are part of something far larger than ourselves, that we may not be alone in this infinite expanse. Whether through the potential existence of extraterrestrial life or the shared fate of all matter in the universe, the cosmos invites us to consider a vast web of interconnectedness that transcends time and space. The universe, in all its mystery, offers more than just an understanding of the cosmos itself. It offers a broader view of our place within it. It invites us to see ourselves not as isolated beings, but as integral parts of a grand, unfolding adventure. In this cosmic journey, we are not merely passengers, but active participants. We are explorers, ever on the verge of discovering something new about the world, our place within it, and the universe that surrounds us. It is in this exploration that we find meaning, wonder, and the shared hope that one day we may come to understand the infinite complexities of existence. The pursuit of knowledge about the cosmos unveils not just the vastness of space, but also the remarkable resilience and ingenuity of humankind. From launching spacecraft that venture to the distant reaches of our solar system to creating powerful telescopes that peer into the distant past, Each milestone reveals our ability to rise to the challenges that the universe presents. These feats are not merely scientific triumphs, they symbolize the strength of human creativity, collaboration, and determination. With each achievement, we are reminded that no matter the obstacles, we have the tools, the minds, and the will to overcome them, and the desire to explore the unknown. These extraordinary efforts to understand the cosmos ignite hope for the future. As we continue to unravel the mysteries of space, we are constantly reminded that, although the challenges are great, the possibilities are infinite. This ongoing journey calls us to push forward, to question, to seek, and to wonder about the origins of our existence, our purpose, and what lies beyond the boundaries of our current understanding. Every new revelation about the universe adds another piece to the puzzle of existence, propelling us forward with awe, wonder, and an insatiable curiosity. It is this collective drive for answers that binds us together across cultures and generations in a shared quest to make sense of the universe. In exploring cosmic anomalies, we do not only uncover secrets about the universe we inhabit, we also come to understand our own place within it. The legacy of such exploration, ideally, will inspire future generations to cultivate an ever-deepening curiosity about the cosmos. As we study these anomalies, whether it's the mysterious nature of dark matter, which seems to bind galaxies together, or the perplexing behavior of black holes, we are uncovering stories about the very fabric of our reality and the fundamental forces that govern it. By peeling back the layers of cosmic secrets, we inspire a sense of wonder that transcends generations. Young scientists, astronomers, and curious minds will take these discoveries and push them further, crafting new technologies, forming new theories, and venturing into realms of exploration that we cannot yet fully imagine. New fields of inquiry await, such as quantum physics or the study of gravitational waves. Future scholars might develop methods, tools, and perspectives that radically transform our understanding of the universe. This legacy is not only about the scientific advancements we achieve, but also about fostering a mindset that values inquiry, creativity, and collaboration. It is about planting seeds of inspiration that will inspire the next generation to embrace the challenges of discovery. The journey of exploration is, above all, a collective human endeavor, one that celebrates the innate drive to explore and understand the unknown. As we delve into cosmic mysteries, we lay the foundation not just for breakthroughs in science, but for a culture that celebrates curiosity, inquiry, and the thrill of discovery. This culture, in turn, encourages a deep respect for the unknown, reminding us that there is always more to learn, to discover, and to marvel at, no matter how far into the universe we go. The concept of the universe's edge, a tantalizing notion that captivates both scientists and philosophers, challenges us to rethink the very fabric of reality itself. When we ponder the boundaries of the universe, we often wonder, what lies beyond it? Is it a vast emptiness, another universe entirely, or something far beyond the scope of human comprehension? These questions stretch the limits of our imagination and invite us to rethink the very nature of existence. One of the most compelling theories related to the universe's edge is the concept of cosmic inflation, which proposes that just moments after the Big Bang, the universe underwent a rapid exponential expansion, stretching far beyond the limits of what we can observe today. The realization that what we can see is only a fraction of the entire universe humbles us, reminding us that our knowledge is limited and that there may be realms, dimensions, or states of being that lie completely beyond our reach. Moreover, considering the universe's edge invites us to think about time and space not as fixed and rigid concepts, but as fluid, adaptable dimensions. Could space itself curve back on itself? Might time behave differently at extreme distances? These tantalizing possibilities force us to reconsider our everyday experiences of reality, expanding our understanding and opening our minds to the unexpected. By grappling with such ideas, we not only advance our scientific knowledge, but also expand our philosophical horizons, forcing us to confront questions about existence, consciousness, and the nature of the universe itself. Ultimately, the contemplation of the universe's edge is an invitation to embrace uncertainty and wonder. It challenges our assumptions about reality and encourages us to remain curious and open-minded in a universe filled with mysteries. This kind of exploration is not just about seeking answers, but about appreciating the journey itself, understanding that every question we ask about the cosmos unveils new layers of complexity, awe, and possibility. It is about the excitement of discovery, the joy of asking questions, and the inspiration that comes from contemplating the infinite. Cultivating a sense of wonder about the universe begins with making the incredible accessible to everyone. By sharing the awe-inspiring aspects of space exploration, we allow individuals of all ages to experience the thrill of understanding cosmic phenomena. Engaging storytelling that weaves together science, history, and personal narratives can be particularly powerful in this effort. For example, by highlighting how ancient civilizations offered the first glimpses of celestial bodies and contrasting that with the sophisticated technologies of today that allow us to explore distant galaxies, we can inspire a sense of wonder in audiences everywhere. Interactive experiences play a crucial role in this endeavor. Planetariums, science centers, and public lectures provide individuals with opportunities to immerse themselves in the cosmos. Hands-on exhibits, such as those that simulate space travel or demonstrate the relative size of planets, create tangible connections to the vastness of the universe and make it easier to appreciate the scale and beauty of what lies beyond. By bringing the cosmos to life in such accessible ways, we open the doors to a broader with the wonders of space, with the wonders of ensuring that the spirit of exploration continues to thrive for generations to come. Imagine stepping into a world where technology and artistry come together to weave an immersive tapestry of the cosmos, where the universe is no longer a distant realm, but an accessible, tangible wonder. Thanks to the rise of digital technology, virtual reality experiences and mobile applications have opened new avenues for us to journey through the vast expanse of space. These tools offer us the chance to witness celestial phenomena up close, transforming abstract concepts into awe-inspiring realities. By blending the realms of art, culture, and science, we not only explore the cosmos, but connect emotionally with its wonders. Art, in particular, has a unique ability to communicate complex scientific ideas in ways that resonate deeply with people, inviting us to engage in a dialogue between intellect and emotion. Collaboration between artists and scientists has led to the creation of breathtaking visual narratives and performances that elevate our understanding of the universe. These collaborative efforts often take center stage during special events like International Space Days, star parties, or public viewings of cosmic events, each one a celebration of discovery that brings communities together. These gatherings foster a shared sense of wonder where people from all walks of life unite to marvel at the cosmos. It is in these moments of collective awe that the boundaries between the known and the unknown seem to blur, giving birth to a collective sense of curiosity and exploration. Encouraging a spirit of inquiry is crucial in nurturing this sense of wonder. Supporting educational programs that focus on astronomy and the sciences from an early age lays the foundation for a lasting curiosity. These programs not only teach the mechanics of the universe, but also spark the imagination, prompting questions about black holes, dark matter, and the latest astronomical discoveries. The conversations that arise in community forums and online platforms keep the flame of curiosity alive, reminding us that the universe is an ever-unfolding story, filled with mysteries waiting to be unraveled. This quest for knowledge is a testament to the remarkable resilience of human curiosity. As scientists push the boundaries of our understanding, they often find themselves faced with new mysteries that prompt more questions, questions that fuel further exploration and innovation. The pursuit of answers becomes a delicate dance between certainty and uncertainty, with each discovery leading to more inquiries, each opening the door to new realms of possibility. Sometimes, the answers we seek challenge our very perceptions of reality. Quantum mechanics, for instance, introduces us to a world where particles can exist in multiple states simultaneously, fundamentally shaking our understanding of causality and determinism. Embracing these complexities is crucial because they remind us that knowledge is not a static endpoint but a dynamic process, a journey marked by continuous growth, reevaluation, and new understandings of our place in the cosmos. The pursuit of knowledge transcends the boundaries of science. It stretches into philosophy, art, and ethics, weaving a rich tapestry of interconnected ideas. As we venture further into the unknown, we are forced to reflect on our own existence, confronting timeless questions that have haunted humanity for centuries. What is our purpose? Are we truly alone in the universe? Each exploration into the vastness of space not only deepens our scientific knowledge, but also strengthens our connection to the universe. It encourages a sense of belonging, a realization that we are not mere observers, but active participants in the unfolding story of existence. This understanding enriches our shared human experience, uniting individuals from all walks of life in a common journey. As we navigate the cosmos, we uncover not just facts and figures, but a deep well of inspiration, an invitation to embrace the unknown and explore new vistas of imagination and discovery. Humanity's relationship with the cosmos is on the brink of a profound transformation. As our technological capabilities advance, we find ourselves with the tools to do more than just observe the universe. We can now interact with it in ways that were once unimaginable. Future missions to celestial bodies like Mars and the moons of Jupiter and Saturn could provide the first steps toward human colonization or resource extraction beyond Earth. These ventures into space are not merely about survival or expansion. They are driven by an innate curiosity, an unyielding desire to explore the unknown and understand our place in the grand scheme of the universe. The rapid advancement of astrophysics and astronomy is deepening our understanding of the cosmos. We are unraveling the mysteries of dark matter and dark energy, two elusive components that make up most of the universe, but remain hidden from direct observation. The discovery of exoplanets within the habitable zones of their stars has sparked discussions about the potential for life beyond Earth, fueling the possibility of astrobiological exploration. As our knowledge grows, so too does our ability to imagine new futures that may involve interstellar travel or communication with extraterrestrial intelligence. Culturally, our relationship with space is shifting. No longer are we passive observers, gazing up at the stars with wonder. The rise of space tourism has made it possible for more people to experience the beauty of Earth from above, fostering a greater appreciation for our planet as a fragile oasis in the vast expanse of space. This shift in perspective is leading to a renewed sense of responsibility, not just for Earth, but for the celestial environments we are beginning to explore. The philosophical implications of our expanding understanding of space are profound. As we look outward, we are prompted to look inward, questioning what it means to be human in this vast, ever-expanding universe. These reflections can unite us in a collective effort to explore, learn, and safeguard life, both here on Earth and beyond. As we embark on this journey, we are reminded that our connection to the cosmos is not just scientific, but deeply existential. In this quest for knowledge, the visual arts serve as a unique bridge, helping us comprehend the complex phenomena of the universe. Artists have the remarkable ability to depict concepts that are difficult, if not impossible, to articulate with words alone. By translating abstract ideas like black holes, dark matter, or supernova into visual representations, artists invite us into the emotional and intellectual wonder of the universe. These artistic interpretations can evoke a sense of awe, encouraging viewers to contemplate the mysteries of existence. A striking example of this is the way artists have portrayed black holes. Often depicted as swirling, dark vortices, black holes are shown as consuming everything within their reach, a powerful visual representation of their mysterious and often frightening nature. Such depictions stir our imagination, urging us to ponder what lies beyond our understanding. Similarly, artists may use vibrant colors and dynamic shapes to illustrate the cosmic microwave background radiation, a remnant of the Big Bang that continues to permeate the universe. These artistic representations of the invisible bring the unseen into view, sparking curiosity and inviting deeper exploration into the origins of the cosmos. Thus, the integration of science, art, and technology creates a compelling narrative that not only allows us to observe the cosmos, but also to participate in the ongoing story of its discovery. It is through this dynamic interplay that we are reminded that the universe is not a distant, abstract concept, but an ever-present, evolving entity that invites us to explore, reflect, and ultimately understand our place within it. Mixed media, in its diverse forms, offers artists a unique opportunity to fuse the realms of science and creativity. By harnessing these innovative techniques, they can craft installations and paintings that don't merely represent celestial phenomena, but actively engage with light, space, and movement in ways that mimic the behavior of distant stars and galaxies. Integrating cutting-edge technologies like projection mapping or virtual reality, artists can immerse their audiences in simulations of cosmic events, visualizing phenomena that would otherwise remain beyond human reach. These interactive experiences do more than just engage our intellect. They stir our emotions, offering a profound sense of connection to the vast, often abstract universe. A well-designed piece of art doesn't just make the cosmos visible, it makes it feel personal. Through this artistic lens, the distant stars become tangible, the unknown feels accessible, and the grand mysteries of the universe shift from being remote to becoming relatable. The visual arts, in essence, extend an invitation to reflect, question, and explore the infinite beauty of the cosmos, offering a space for contemplation while bridging the seemingly unbridgeable divide between science and human emotion. The true magic of art, particularly in the realm of cosmic exploration, lies in its ability to simplify complex scientific concepts, making them accessible to anyone, regardless of their background or education. While the language of science often relies on numbers and equations, art speaks to the soul. As viewers stand before a canvas or within an installation, they are not just witnessing a representation of the cosmos, they are participating in a larger dialogue with the universe, an invitation to journey deeper into the unknown. Each brushstroke or projection becomes a doorway to new questions, expanding the viewer's curiosity and imagination, propelling them into the realm of discovery. Literature, in tandem with visual arts, has long been a mirror to humanity's deepest philosophical questions, particularly regarding our place in the cosmos. Through vivid narratives, authors have drawn us into the vast unknown, exploring the boundaries of space, time, and human understanding. At the edge of the universe, where the laws of physics begin to blur and the mysteries of existence deepen, literature offers a path to understanding. Novels, essays, and poetry weave imaginative narratives that allow readers to engage with abstract scientific ideas on a deeply personal level, transforming them into accessible concepts that anyone can grasp, regardless of their scientific knowledge. In this age of scientific revelations, such as the discovery of black holes, dark matter, and the ever-expanding nature of our universe, these literary works play a critical role in demystifying complex ideas. As the boundaries of cosmology stretch further into the unknown, literature provides an entry point for the general public to engage with these discoveries, fostering a broader dialogue between the scientific community and lay audiences. Through the power of storytelling, authors can translate the intricacies of the universe into vivid tales that are not only accessible, but emotionally resonant. This bridging of the gap between scientific inquiry and personal insight is a crucial step in making knowledge democratic. Literature brings the abstract to life, putting the farthest reaches of space within the grasp of every reader, even those without formal scientific training. But beyond the scientific realm, these stories spark critical conversations about the ethical implications of discovery, the societal impacts of new technologies, and the responsibility humanity holds in the face of these revelations. They raise philosophical questions about our place in the grand scheme of things and our responsibilities to future generations. As readers reflect on these issues, they are better equipped to participate in public discourse, voicing their hopes, fears, and curiosities about the wonders and potential dangers that lie in the vast expanse of space. By creating a bridge between science and the human experience, literature fosters a culture of curiosity, inviting us to consider the cosmos not as a distant, alien entity, but as something intimately tied to our own existence. Every story, whether it's about space exploration or the unraveling of the universe's deepest secrets, adds another layer of understanding, encouraging us to keep asking, to keep imagining, and to keep dreaming. The cosmic narratives we create don't just inform, they inspire, urging us to envision new possibilities and pushing us toward deeper revelations. Music, much like visual art and literature, holds a special power to convey the grandeur and mystery of the universe. It taps into the emotional depths of the human spirit, offering us a way to connect with the cosmic unknown on an entirely different level. When we listen to orchestral compositions inspired by the cosmos, like Gustav Holst's The Planets, the music doesn't just fill the space. It makes us feel as though we're part of the very fabric of the universe. The movements of celestial bodies are echoed in the sweep of strings and brass, and the rhythms of the stars seem to pulse through every note, reminding us of the vastness, power, and majesty of the cosmos. Through these musical compositions, listeners embark on a journey through the cosmos without ever leaving the comfort of their seat. Each movement evokes the feel of planetary motion, the swirling of galaxies, and the dance of the heavens, inviting us to contemplate our place in the universe. These melodies, drawn from the very rhythms of the cosmos, remind us that we are not isolated. We are part of a larger, interconnected universe, constantly shifting and evolving. The music of the stars encourages us to look beyond our own lives and imagine a cosmos teeming with mystery, beauty, and untold possibilities. Composers frequently draw inspiration from the dynamics of space itself, capturing the essence of cosmic phenomena through sound. Modern space-themed scores often mirror the movements of planets, the gravitational pulls between celestial bodies, or the spirals of galaxies, offering a musical representation of space exploration and scientific discovery. The connection between sound and the celestial order becomes apparent in these works, and listeners are encouraged to imagine the rhythms of the universe as they hear the music. Just as the planets orbit in a delicate balance, so too does the music invite us into a universe where everything is connected, where every note, every chord contributes to the larger universal symphony. This unique blend of sound and space evokes a powerful sense of wonder and curiosity, pushing listeners to reflect on the unknown and to dream of what might lie beyond the stars. Music, like art and literature, invites us to explore the boundless realms of the cosmos, making the mysteries of the universe feel not only within reach, but deeply relevant to our own lives. Through the universal language of music, we are reminded that the vastness of space is not something distant. It is something alive within us, calling us to dream, to discover, and to imagine. Music has a remarkable ability to elevate moments of scientific discovery, providing a rich, emotional backdrop during significant breakthroughs. When scientists achieve monumental feats, like launching spacecraft to distant planets or uncovering new galaxies, the music that accompanies these moments often amplifies the impact. The carefully chosen soundtracks heighten the experience, intensifying our emotional reactions and allowing us to feel the weight of these discoveries in a more profound way. In these instances, music becomes more than just an auditory experience. It helps us connect with the implications of these advancements and their broader significance for our understanding of the universe. This connection is more than emotional. It serves as a bridge that deepens our curiosity and stirs our imagination. Music tied to space exploration not only enhances the narrative surrounding the scientific journey, but it also creates a unique atmosphere that inspires us to dream beyond the boundaries of what we know. It sparks a desire to reach out into the unknown and explore the mysteries of the cosmos. Through the harmonies and rhythms, we are encouraged to reflect on the origins of life, the possibility of extraterrestrial existence, and the countless enigmas that surround us. Wrapped in the embrace of these melodic sounds, we gain a sense of unity with the universe, evoking a shared connection to the celestial wonders above. This fusion of music and science fosters an inspiring environment, one where the complexities of space exploration become not just a field of study, but a source of awe and inspiration. As we engage with these sonic landscapes, we begin to develop a deeper appreciation for the extraordinary efforts that go into space research. But more than that, we gain a sense of wonder, reminding us of the infinite mysteries that await us. It is through this shared journey, driven by both scientific inquiry and artistic expression, that we are invited to dream, explore, and ultimately understand the vast, awe-inspiring universe in which we live. The collaboration between artists and scientists plays a crucial role in illuminating the wonders of the cosmos. Together, they can create innovative works that transcend the boundaries of their individual fields, combining the technical with the imaginative to offer new ways of interpreting the universe. Visual art, for instance, becomes a powerful tool for translating complex scientific concepts into tangible forms. Through mediums like painting, sculpture, and digital art, artists are able to represent abstract ideas, such as the inescapable pull of black holes, the explosive energy of supernovae, or the mesmerizing spiral of galaxies, turning these concepts into emotionally evocative works. These pieces provide a unique means of connecting with the public, allowing individuals to engage with scientific phenomena on a personal level and making complex ideas more accessible. Multimedia exhibitions represent another avenue where science and art can merge to create an immersive experience. Imagine an exhibit where visual art and scientific data work in tandem, each enhancing the other. Interactive installations featuring projections of astronomical data, soundscapes of cosmic events, or virtual reality experiences that transport visitors through space offer viewers the chance to engage with the universe in new and dynamic ways. These environments invite audiences to move beyond passive observation and become active participants in their exploration of the cosmos. They foster a deeper understanding of the universe while simultaneously cultivating an emotional connection to the material, bridging the gap between the analytical and the aesthetic. Performance art, too, offers a compelling way to engage with the cosmos. Through live presentations that incorporate themes of science, artists can transform abstract scientific principles into emotional, compelling narratives. Dance performances might evoke the dance of the planets or the celestial bodies in orbit. Theatrical productions could explore the life cycles of stars, from their birth to their eventual death, encapsulating the grandeur of cosmic events in performances that resonate deeply with audiences. These live interpretations make complex scientific ideas more relatable, personal, and emotionally impactful, extending their reach beyond the realm of academia. Moreover, public outreach through community-based educational programs and workshops further solidifies the connection between science and art. Scientists and artists can collaborate to offer educational experiences that inspire participants to explore and express cosmic phenomena through various creative outlets. Whether it be through poetry, painting, music, or other artistic forms, these workshops foster a sense of wonder and curiosity, igniting a passion for both art and science. This collaboration doesn't just serve to educate, it also nurtures a deep appreciation for the relationship between the two fields and the ways in which they can work together to illuminate the wonders of the universe. The integration of scientific knowledge with artistic expression offers a fresh perspective on cosmic phenomena. While science provides the intricate details and theoretical frameworks necessary to understand the universe, art transforms these abstract concepts into experiences that engage our senses and emotions. Without the interpretive lens of art, many scientific ideas, such as the nature of dark matter, the theory of relativity, or the mysterious behavior of black holes, would remain difficult for most people to truly grasp. Art serves as a translator, allowing us to access these complex concepts in ways that resonate with our personal experiences and emotions. For example, a painting that captures the swirling motion of a galaxy can evoke a sense of wonder and awe. A sculpture inspired by gravitational waves might offer a tangible representation of something unseen, sparking curiosity and reflection. Such artistic expressions are not just about aesthetics, they evoke a deeper understanding of the universe, like allowing audiences to connect emotionally to the very phenomena that scientists spend years studying. By intertwining the scientific and the artistic, we are able to enhance public understanding and appreciation of the cosmos. Art and science together make these vast and often abstract concepts more approachable, offering a multidimensional view of our place in the universe. When artists and scientists collaborate, they highlight the human experience within the grand narrative of the cosmos, illustrating that while data and models help us understand the universe, it is through personal engagement and emotional resonance that we come to understand our place within it. Ultimately, the union of art and science not only deepens our understanding of cosmic anomalies, but also fosters a culture of inquiry and creativity. By weaving together the facts of science with the emotional power of art, we cultivate a richer appreciation for the cosmos and invite others to share in the exploration of the unknown. In doing so, we align ourselves with the infinite wonder that surrounds us, allowing our minds to wander freely among the stars, contemplating our existence within the vast and mysterious universe.